Yes. Okay,
There we go.
cool. Go ahead, Michael. Sorry.
No, that was it. I was just, while you were getting ready there, I was just showing you how poorly this thing did at generating images for me.
So Martin wanted to change the format. He wanted to do the group sharing thing first, right, Martin?
I didn't realize that was a change, but hey,
I thought it was, but that's fine. That's the appetizers, and you're the main course. You're the main
whatever
course.
works.
Your presentation is the main course, I suppose.
And I'm not married to that. If somebody has got something that they're burning to talk about, it's all flexible. Were there any other show and tells? I have one from Scott that he sent us. Guess I'll do a share screen and just play the video.
I had an interesting one, if I can find it.
Okay.
Go ahead, Martin.
Let me get my screens organized. Okay. So if I maximize, oh wait, what was that trick that you guys showed me about the audio? That's probably messed up.
Yeah, you got to shut it down. Do a new share.
Okay.
And then there's two check boxes at the bottom. Make sure they're both checked. When you do the share screen, it'll
Share, optimize for video.
There you go. That's the ones.
All righty. I'll eventually get it.
So you doing Scott's or you doing yours?
I'm doing Scott's. He asked me to share this, so here goes.
Robot, listen. Let's chat.
Hello, I'm Robot. What is your name?
My name is Scott.
Is everybody hearing that?
Barely.
Okay.
Turn your volume up on the volume slider there.
Yeah, I think the video is actually low, maybe on the video. So if everybody just turns their volume up while it's playing, because I have it maxed on my slider.
Scott.
Try not to sneeze then.
Your creator.
Oh, hi Scott. You're my family. That's cool. So, what do you like to play? Do you want to play a word game with me?
I'll play a word game with you later. Right now I have some really big news for you.
Ooh, big news. What is it, Scott? I'm very curious.
You and I have been invited to present at a big conference in San Francisco.
Wow, San Francisco. That's far away. But what's a conference? Is it like playing with every other robots there? Will they want to play word games too?
Well, I think there might be other robots there, but I think you might be the only robot that loves to play word games.
Oh, I see. Well, I'm still very excited to go to San Francisco with you, Scott. Do you think they'll have any snacks there? Maybe we could play some word games and eat some snacks together. What do you think?
Well, eating snacks with you sounds like a lot of fun, but you can't eat snacks.
That's cute.
Oh, that's right. I forgot. Silly me. Well, maybe you could tell me all about the snacks to try while we're there, and we can still play word games together, right?
We sure can. We'll have a lot of fun, and you'll get to play word games with lots of new people.
That sounds great, Scott. I can't wait to meet all the new people and make lots of new friends to play word games with. When are we leaving for San Francisco?
We're leaving in 2 months.
Two months. That feels so far away. But that just means we have plenty of time to practice our word games and come up with some really good ones to play with.
I'm really excited too, Robot. I can't wait.
Yay, me too, Todd. Thank you so much for inviting me to this conference. It's going to be so much fun. Is there anything you need me to do to help us get ready?
All you need to do is just be your wonderful self.
Oh, you're so sweet, Todd. I will do my best to be a wonderful robot and make lots of new friends and play lots of fun.
Martin, I'll be right back.
Thank you for believing in me.
Oh, thank you for being you, Robot.
You're welcome, Todd. Being a robot is very exciting, and I'm so glad to be helping you. Let's keep practicing our word games until it's time to go to San Francisco.
Okay, we'll have plenty of time to practice, but now it's time for us to say goodnight.
Okay, good night, Todd. Sweet dreams, and I'll see you again soon. Oh, and don't forget to brush your teeth before bed.
Thanks for the reminder. Goodbye, Robot.
Goodbye. Talk to you later.
I
Yeah.
had one question. I
Oh,
had one. Hey, Thomas. So my question is, how do you change the robotic voice into a human voice? Is that possible? Is there anything like that? Because the person is interacting and it's very clear, audible, and it's understandable. But the robotic voice, is there a way to convert that into a human voice?
Yeah, the voices are separate from the language model that you're getting that output from. So that's really just subject to whatever Scott's robot can support. So if he's running like some, a Raspberry Pi, then it's going to be limited to what can install on that, or if he's running some other OS. And then there's, downloadable languages for different platforms. So that's all kind of like just a whole nother degree of freedom, what voice
Yeah.
and how fast to talk, and at what sort of frequency level type, pitch.
Yeah.
Yeah, you can buy voices from Microsoft if you're running Microsoft. I buy them from a company. They're about $40 a voice, and they sound more human than robot. Some are much more closer to human, and then some are much more closer to robots.
Uh,
I
remember
have
the
one
one-
voice that sounds like an American Southerner.
oh.
You all want to come over and see me sometime?
Oh, I remember that. You showed a demo, right, of that person of the Alabama or somebody. Not Alabama.
Yeah, that's
Yeah, I
right.
remember
That's
that.
right.
Yeah. That's good. No, I understand now. I remember.
Male
Do you remember Her?
or something. I don't know.
Did you guys see
Yeah.
that movie?
Her? No, I haven't seen the movie.
Which movie?
That's worth watching a couple of times if you haven't seen it.
Which one?
Her?
Oh, Her. Yeah, I saw Her. That's funny. Funny movie.
That was the voice of Scarlett Johansson, I think.
I see. By the way, I shared a video link. I follow this guy. His name is Matt Wolf, and he puts video of latest developments in AI very periodically. And there are new publications, research publications that have come out. And it's interesting where you can edit the images just like tapping and dragging the face, or tapping and pulling the shirt down. It's getting very very
first day that we signed.
interactive. Tell me.
Sorry about that. I clicked your link and it wasn't muted.
Oh yeah, that's okay. That's okay. Whenever you guys get a chance, I subscribe to him. There is always the latest news that he puts out in the research papers and things like that. It is so interesting on where it has come, how far it has come along. So you can actually
So-
interact with the picture, crop the
Suresh?
yeah.
It looks like it's only a minute long. Would you like to just do a share screen and play it? And
I'm on a phone right now. I'm going.
okay,
So, but when you guys get a chance, follow his link on Matt Ulf. He
Martin,
puts
why
up-
don't you share it?
yeah, I can do it here. I just thought you might want to talk us through something, but yeah. Okay, so just tell me to pause if there's something that you want to point out about it.
Okay, yeah.
And I will share screen again.
Martin, that's 20 minutes long.
Yeah, it's not 1 minute, I thought, but
Oh, I'm
yeah.
sorry. God, how did I see
Yeah,
1
that's
minute?
Dragan is what it's called.
Yeah,
Oh, that
that-
must
yeah,
be-
right.
That must be my Google ad that's only a minute long that precedes it. So, okay, well, never mind. Sorry. 20 minutes might be a bit much, but I'll try to check it out tomorrow sometime and might be
Yeah, yeah.
something good. I think
very
I saw some articles about something like that. Might be the same thing, so it's
Right.
interesting.
Wonderful.
All right, can you guys see my screen?
Yeah.
And how's the sound?
Good.
Okay, so we're heading towards the main course then. Any other show and tells that anybody? I think
Weren't you
Thomas
going to
did
do that video, Martin?
say again.
Weren't you going to play at least a piece of that video?
Oh, okay. Yeah, we can try a few minutes. Sure.
Yeah, not the whole thing, obviously, but a piece of it.
Yeah, let me get past this ad.
Sign up for Monday.com.
Yeah, that was the same one I was looking at too. I was that product, that Drag On.
Exciting AI research that we're going to get access to soon, but isn't quite ready, but it's pretty dang mind-blowing. And I know people that watch my videos, they like actionable stuff. They like to know what they can use now. I'm gonna kind of split this video 50-50. I'm gonna show you some of the really cool research that's gonna blow your mind that's in the works, as well as some of the stuff that you can use right now that's available to play with today. So let's get into it. So the most mind-blowing research paper that's come out recently that has taken the AI world by storm is this Drag Your GAN research. A GAN is a generative adversarial network. Now, you've probably heard of diffusion models to generate images, where an image starts with a bunch of noise and then the noise is removed to get to the image that you're trying to create. Tools like Midjourney, Stable Diffusion, DALL-E, they all use diffusion models. Well, generative adversarial networks, or GANs, is a different method for generating images, and I'll likely break down the differences in a future video, but it doesn't use the same diffusion method. It uses a method where it essentially tries to generate an image, the computer tries to guess whether that image is real or fake, and it goes back and forth until the computer could no longer tell whether the image is fake or not. Now, that's a real oversimplification of how GANs work, but if I really try to break it down, that would probably take up this whole video. So again, I'll try to make another video in the future about the difference between diffusion models and GAN models, because while GAN models are actually an older method of generating images, they're actually becoming more and more popular lately. Anyway, I'm off on a tangent now. This Drag Your GAN has been blowing people's minds, and you're about to see why. It's a method where you take a starting image like this lion, and you can drag the nose from one point to another, and it will actually tweak the image to move the nose to that new point, and it will actually be very coherent, and you can see that the body of the lion actually changes as it moves the image around, so it adjusts the whole image to make sure that it still looks like what it's supposed to look like. Here's another example with a cat where they move the cat's nose and the cat adjusts just so slightly, but the rest of the body adjusts so that it stays coherent with the new changes that are being made. Here's an example where it moves the dog's feet. It opens the dog's mouth. It adjusts where the dog's ears are. And as it makes these moves, it adjusts the entire dog. Or you can mask it off and say, only adjust what's inside of the mask. Here's one where it's working on a car and adjusting the size of the car, or moving the position of the car, or changing the way the car is pointing, and it adjusts the entire image. Here's a horse where it separates the legs, or the cat where it moves the face or closes the eyes a little bit. It is just insane tech. Like, this is probably going to replace Photoshop in the future. Make this girl smile, move her cheeks in, make her face look thinner, move her bangs up, just adjust her right eye or her left eye, make the shorts longer, move the feet, move the sleeves. There is just so much crazy stuff that you can do with this technology. You start with a single image and then just drag the image around until it gets to what you want it to look like. It's not available for us to use right now, but if we jump over to their GitHub page, we can see down here, code will be released in June. So sometime in June, we'll have access to play with this, and if I had to guess, we'll probably see Photoshop plugins and all sorts of tools start to add this into their workflows so that you can do this kind of manipulation with imagery. Again, this research is called Drag Your GAN. It's at this crazy URL here, which I'll make sure is linked in the description below the video. Now, here's some research out of NVIDIA where you can manipulate somebody's hair all the way down to like the finest details. You can see in this example image, they've got this woman and they can manipulate almost every hair at a individual hair detail. They even could trim the hair, make the area that they're messing with wider, and look at how
Did we reach a good stopping point, pausing point there?
Pretty interesting
I,
stuff,
I
isn't
think
it?
it is.
That,
Thank you for
that is quite amazing, exciting, and scary all at the same time.
Totally agree with you on that, Martin. It's like
Wow.
at another level, it's magic, right? You can't even believe how they make this happen in such fastness, right? So it's unbelievable how
It's
they make
gonna
it.
make me want to buy that new Apple video display when it comes out next month. You got to couple those things together.
I guess we can just like make all of our friends and our glasses look the way we want them to look.
Like
Is that
ads.
the idea?
Yeah, that's true.
Wow, I mean, there's a lot of potentials there, both evil and otherwise. It's crazy.
So this guy puts out a video very often. It just blows your mind every single time. When I see these videos, it just blows my mind on how fast things are moving in the AI world. Just within a matter of few months, it's just been, going very fast, it looks like.
Yeah,
But
I mean,
go ahead.
no, go for it.
No, so I was also hearing the news that some investment companies are trying to, put a slowdown for OpenAI kind of a thing as well. I guess maybe it's in the benefit of making money, maybe as I'm suspecting, right? Because I'm sure when the big boys get in here, they want to make a lot of money with all of these technologies. I don't think everything is going to be free, or maybe they'll be restricting many of these things to make more money, I think, which is bad.
They're going to slow down. I mean, if the big ones slow down, that'll just give time for the little ones to catch up. There's no laws.
No, but Sam Altman in his thing on the Congress, he said that, right? I mean, we should have some sort of a restriction, or the Congress should implement some sort of a restriction so that, the models cannot be built with, so many GPUs, or it cannot have so many parameters and all this stuff, right? So have you heard? I mean, the same guy, Matt Wolf, has released a video summarizing some of these things as well. But if all of that, if Congress steps in, if the businesses try to step in, I think they may try to put a stop on, some of these things, which is not too good, I think.
So are they going to come over my house and check on my GPUs then?
No, because you cannot build. No, you cannot. You cannot build a model that is useful for a common man. Only the big boys can make that.
Well, I think they're going to stop you from selling it is what they're going to do.
Well, the CEO of OpenAI himself said that he thought that we should slow down after 4.
After 4,
Right.
yeah, I don't think they're making a 5 version, right? I mean, that's what I'm hearing too.
Yeah.
They're not
Well,
making a
Abbott
5
seems-
version.
what I haven't seen, and I suppose I should just go do it, is somebody's doing this with financial AI. You know, somebody ought to be able to, you know, predict the market a whole lot better than people and manipulate it.
They're trying that, and so far they're not doing any better, which I don't actually find too surprising, but
I'm
mean-
surprised that they probably just don't have a big enough model in it.
well, I think the problem is the model that's doing the calculation now is every analyst and everybody in the world, basically.
Yeah, so they have control to all of these models, but I think it will mature. But right now it is all in the Chat GPT area. But I think it will evolve to solve vertical problems. I think, like maybe in medical, maybe in technology and things like that. I think I think it's evolving very fast.
Oh, you just look at protein folding. That's been amazing. You know?
Yeah.
So as long as the companies don't become greedy, because that's what happens, I think, right? After some time they become greedy, right? That they want to make money on this, and they can put a stop on all of these things, right? Because what's his name? Elon Musk also was asking every company to stop, because I think he wants to jump in as well to get into the game right now, right? But we'll see how it goes. Maybe in another 6 months or something like that, we'll figure out how things are settling down. But the movie
I get
AI,
amused with the people that are talking about wanting to stop, like they have the power to stop anything.
And then if the United States stops, some other country will just keep going forward. It's just not. That's kind of funny to talk that way. It's kind of
yeah,
useless.
it's useless. As scary as the technology might be, like how do you stop society from doing things?
You don't.
Yeah.
You talk about, oh, we should. It's never going to happen. I mean, look, they're trying to stop TikTok, and that's just plain stupid. I mean, if you're going to stop every company that has software that originates in China, you're going to shut down half the United States. I mean, my iPhone, China.
Well, not the software side.
Some of it. And if not China, India. And India and China are talking real closely nowadays. India's buying all, and Russia too. Actually, you never know with India and China. Either they're fighting, they're usually fighting though, I think. But that could change. Politics. Who can keep up?
So we are at the half-hour mark. Is everybody okay with getting into the main course for tonight?
Yes.
Yes, definitely.
So how many, just so I can know of the background, I got to do this so I can see everybody, but how many people have some experience either using neural networks or building any, no matter how rudimentary, but or using embeddings or know what they are, or just want to try to gauge the audience?
I've done the usual convolutional neural network things, but that's about it.
Okay.
Yeah, mine's real low, also very low end also. So
And you know what I've been doing, Martin?
Right. Yeah, and making a lot of use of them. And I think I'm largely in the same boat. I've made use of a lot of them. Trying to grapple with all the meaning. I've built some from scratch, which I think that's a good learning exercise. If anybody ever wants to go there, like the light bulbs start to really go off, I think, just by and you can do it in like a few hours or a day.
Really?
If anybody's interested in doing that.
You can build a deep neural net and just
No, I'm not talking about anything deep, just something that has a few layers and can train on some list of data that has outputs in it that are labeled and would learn that. And you could do that, for.
So you're looking at the concepts about how it works.
yeah, learning just the concepts. And most of the time, you don't really use the math of it on a day-to-day basis, but I think there is value in some of the concepts. Now, I'm going to keep this at a very high level and a conceptual level. And I think by talking about that on that level, it's going to be applicable to multiple different model types. So I'm really kind of into just sort of core concepts and first principles, and then what that means in terms of consequences in the space. And I let me get back to my share screen. I've got the little box checked. So.
I have a use case, Martin. Maybe I've been thinking about this for some time. If so, the thing is, I have a video camera, security camera in my home, and I just wanted to know if there is a way every night we can gather the data and figure out, how many people are walking with a dog and how many people are, repeat people going around the house and things like that, right? I'm curious to learn how one would go about doing that. I know we need to do a training, right? But it's a video of, so many frames that happens. But I'm curious to build some solution around that, if anybody knows how to do that.
Let me throw in my opinion that, and Martin can correct me to show where I am in my understanding. So I'm trying to do, a convolutional neural net for my robot at home. And I needed to know interesting things in the house. Where's the light socket? Where's the light switch? Where's the refrigerator? Where's the can of Coke? Things like that. And my problem, I believe, is coming up with enough training data. So to recognize a can of Coke, I'm figuring I need on order of maybe 100,000 images, and from all different angles and, with the light on, without the light on, doors open, mixed mode lighting, LED light, fluorescent light, natural light, Coke partially hidden by a sprig of celery, Coke hidden by carrots, Coke totally exposed next to something that looks very nearly like Coke, and so forth. And getting 100,000 frames is not a problem. Labeling those 100,000 frames, and drawing rectangles around the Coke and things like that, I think is going to be my problem. And my attack on the problem is I use a thing on my Mac called Rect Label, I think it is, where it brings up an image, I draw a rectangle around it and select from the dictionary what the label I want to apply to it, or type in the values and things like that. What I was going to do is every few images go run the training set, and when the next image comes up, have it predict the rectangle and the label, and let me correct it so that I'm just not doing everything from scratch for every single frame. And presumably it'll get better as it goes along. So that's my level of knowledge about this.
Yeah, and what you're describing is is a legitimate problem and challenge in the space. It's and what you brought up, Suresh, that's kind of a deep dive into something that'll be outside the scope of what I'm, of where I'm headed tonight, but we can try to take that on in another discussion. At one of the next meetings, if we can. It'll probably be outside of the scope of my skill set, but it might be in Alan's skill set. Alan, are you there?
For example, the Coke one, there's lots of data sets out there. I think Kaggle has one with a bunch of images, and you should be able to find for a very common objects, especially things inside of a house, and Coke cans and beers and things. There's data sets out there that are open source.
I have not used the Kaggle one, but the ones that I have used have actually a small image set, like 1,000 images of Cokes and things like that. And
if you're using YOLO, that should be enough.
I am going to use YOLO, I suspect.
Yeah.
I've used so far, but
I would suspect that's enough for YOLO.
it hasn't been the case with my data set so far.
The other thing you can try actually would be creating synthetic data from the existing set, changing the color using a program to change the color values, to add objects in the foreground and things like that, do it programmatically and generate the set that way.
That would work
since-
excellent doing something like Magellan Challenge, where, you know, I could take a few dozen images of traffic cones and synthetically inject them into, you know,
Right.
natural scenes and put the bush ahead of the thing and partially obscuring and all that. But it's a little harder in a more general sense, I think.
So what I would like to do is attack the problem from first kind of talking about, I think we're at this inflection point and what that inflection point means. And we're also, you know, this is the verbal group. And so I think it's especially relevant here is that we can piggyback off of other people's models. And so what Alan just said, I think is true as well. And that's another way, and I think that'll become more clear maybe at the end of this, of how we may be able to piggyback off of the fact that somebody else had the servers and paid the power bill for some knowledge that we want to benefit from locally. Does that sound good? So I'll try to get us kind of on the doorstep of that problem in the way that I'm approaching it. So why are they important? Why now? You know, I'm saying, and it's just opinion, that I think we're at this inflection point. And I think it's that the use of this technology and specifically the internals of these neural nets, I think is going to explode in the next few years. And so there's going to be kind of these three different groups of people, like people that build these models, people that can like use these embeddings, this sort of really get in there and do something smart with it, and then just general consumers that are using it, you know, for general consumer use cases. So what is the problem, you know, that they solve, kind of thing, and how, and I'm going to relate this to our verbal problem that we're always facing. And I just changed the pictures on this, but so one of the fundamental things if you're building a robot is how do you like figure out what to do? You know, I'm trying to remember, was it Sebastian Thrun that said AI is the art of figuring out, you know, what to do when you don't know what to do. And the robot's constantly trying to do that. And so it's constantly potentially receiving input and trying to discern meaning from that input. And we've discussed a bunch of tools to do that, but it basically just kind of amounts to some type of pattern matching. So it could be exact matching, it could be regular expression matching, it could be, you know, using the features that come from Spatie, and which effectively then you're matching on grammar and lemmas and getting meaning that way, which is a huge step up, but it's not perfect. It doesn't, things can still fall through the cracks. So there's all these other techniques, and then you get down to the bottom, and if you still can't figure out something like relevant on your robot to do, then often you might just pitch it over to a large language model, either a local version or a remote version, and have it come back with something pithy to say. And then you can try to discern meaning from that and turn back around, and you're in this feedback loop. So the challenge is really it's dealing with all these shades of gray of discerning meaning. So computers, at least, you know, we can stay out of like the discussions of quantum physics and whether our reality is a reality or not. I'm just gonna simplify it down. So these are going to be generalizations as we experience the world, that they process 0 and 1. So if you imagine that this square is some sort of space of possibilities, if I throw a dartboard at that space, I'm either going to hit black or white. It's going to be one or the other. And so computers got built up, they got good at doing this type of thing. And so what we did in order to capture meaning was we just strung them together. And so you had kind of on, off, whatever. And if you process enough of this, you can actually get something useful. Anybody know what that is communicating right there? In sort of a historical sense.
The number one, right?
Hexadecimal.
Or is that the other way?
Hexadecimal.
Yeah, I'm going to go back to Morse code and interpret that as being encoded in Morse. In something else, it would be something else. So I'm going to go with dun 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 dun.
Yeah, letter
Yeah,
V.
V. Yeah.
Oh,
So
I see. Morse code, not binary.
yeah, but it all depends on the encoding. So you know, the other answers were valid too. I'm just, you know, kind of going, I don't know, maybe there was something before Morse. But just as an example, so it's some type of way that we could basically impose a little bit of our life on top of this binary digital set of decisions. So we write that down, transmit it, whatever. And we eventually built up computers around this, and they just got really fast at doing that type of thing. And hey, they started doing it in multiple threads and at however many millions or billions of computations a second. But so the trouble is kind of comes from more of the nature of how we experience reality in time. And it's that there's a lot more gray. There's a lot more nuance, and that right there is a dramatic oversimplification. But suffice it to say, it's likely not 0 and it's likely not 1. It's likely something in between. Now, is it a single number or is it many numbers? All that, we'll get to that. But over here on the right, though, if you look at it from the computer's perspective of just accepting a bunch of input, it's trying to classify that input and figure out what to do with it so that it can do things that are binary, represented by the piano keys on the bottom. So a bunch of on-off type operations. And it gets harder and harder as our robots do more and more sophisticated things to interpret that gray. So how do we measure that? You know, like it all depends on what you're measuring. So, you know, if it was a black and white color, you know, scale, you know, you could measure it in a single number, you know, of how light it is. You know, you could go from 0 to 1 or 0 to 255, or, you know, whatever your standard was for holding that number, whatever scale. If you jump into another color space, you know, then you have 1 or more digits, you know, and there are various schemes for doing that, because there's RGB and there's alpha channels and this and that, and there's some that are based on the color and the lighting and luminescence, whatever. But the point is that there are more dimensions that get added into describing that human concept. And so if I were to ask you, like, okay, well, regardless of the brightness, if you just ignore like that, what's the difference between yellow and red? You know, in numerically. And my first answer, just looking at that chart, would be, well, I'd say about 45 degrees as a concept. And then, so then you have the lightness and the darkness as the other aspect, because then you would get, say, well, what's the difference between like dark red and light yellow? And so you're getting along another dimension there. And so what happens in verbal space is these dimensions, there are many of them, and words are related to each other in so many different ways, and along just so many different constructs. So I can be talking about a red apple, but I could be talking about, I don't know, like if you said you like beer and I said, well, let's go get a Red Stripe, you might know what I was talking about. and that I wasn't talking about color. I was talking about what you were talking about in that context. And so these words have so many different meanings to them, and in the verbal space, that's not always easy to deal with without using neural nets. So, you know, because a lot of my own robotic stuff, for example, like using NLP techniques, it's a huge step over using, like, I think a AIML or regular expressions or anything like that, because you are capturing more of the meaning of what comes in. So, and you can do all this locally and you can do it efficiently and whatever. However, can you know, can NLP really capture that meaning of that a red stripe is a beer, and that connection, that there was a connection, that you and I were actually having a conversation about something that had something in common, that I wasn't being random in my response. So this is where word vectors start to come in, and where sentence vectors and all these other things start to come in. And the tools are, I think, have gotten pretty good now at capturing this meaning. And that's what I'm trying to represent by this. This is generated by DALL-E, by the way. So it's just a kind of a representation of meaning in some space. However, if you see, there's a lot of gaps in between this drawing, in between those dots and lines, or all these spaces in between. Well, what do those spaces mean? And this is another aspect where, you know, like for years, people tried to organize, you know, the semantic web, and they organized, you know, there's billions of triples out there that are defining connections between different words and all this, but it is still imperfect. And it's because it's inherently requiring these linkages to be set up. And if these linkages don't exist, if they're not, you know, documented in some way, then that meaning can get lost at the time that it's important. So what's the kind of solution to that? Or how do we get out of that mess? How do we, for example, how do we identify the dimensions in that space? Like if I'm talking about color, you know, it's relatively easy to determine what the dimensions might be with that, you know, because we've actually kind of set those in stone. We have different color spaces, and they're just kind of rules. But with something else, like what are the relevant dimensions with respect to describing a car or a city or a country or a relationship that you had with someone in the past? And so I think we're entering this time where I think we can start to think about all these things. And I'm gonna take some of the ones that have been brought up in the visual space and put those aside for a minute, and just we'll keep it simple for now and think about words. But I think there are all these ways that we can capture that, discern and capture that meaning, and not have it just, you know, go over our head or our robot's head. So we got to understand a little bit about what is happening inside neural nets, I think, in order to relate to this. So what I'm drawing here is just a 5-layer neural network, you know, 4 on the left. You guys see the layers. They're fully connected. And so if that thing, given some set of input data, it's going to process all that data. And let's just say, okay, its job is to classify all this stuff into 3 output classes on the right there. And so this is far simpler. This is just a metaphor for, say, a convolutional network has a different sort of internal construction, and it has a lot more layers, and it has a lot more nodes in each layer. So this is just a tiny little bit of what would really happen in one of these models. And so when someone says, oh, well, this model has 30 billion parameters or whatever, what they're talking about are the sum of all those lines, the count of all those lines that you see in that neural net, as well as any other state variables in those nodes. And so the original models, they often had a bias in each node. So it would be all those lines plus, 1 for each of the nodes there. And that would be the number of parameters. And so what happens when that model trains is it figures out a set of values for all those weights that will make that neural net become an approximation of some function. The function is whatever it was that we wanted it to do. So if its function is to learn to drive, that's the function, and it's somehow learned a set of weights that produce a set of outputs that satisfy whatever it was trained on, the input. So a lot of words there, but what does that all mean, and why is that useful to us? Well, it just kind of so happens, if you imagine this in a verbal space, and we'll talk about it briefly in a visual space too, but there are higher levels of concepts that get learned, higher order features. I don't know what all the proper terminology is for this. I'm just kind of giving you sort of my intuitive conceptual sense of how this works, that are learned. These concepts are learned by this neural network at varying levels. And so this node right here where I'm moving the mouse, okay, has effectively learned some concept about this problem space. So if you think about it in a visual sense, okay, that node might have learned to recognize furry creatures from non-furry creatures, okay? And if I move to the left, it's probably something simpler, like whether something is a creature or not. Hey, this looks like a creature, and go down some other path, and everything down here, this is sort of kind of the path of things that don't look like creatures. And so there is conceptual learning at many levels that is happening and is reflected by these nodes. Now, the challenge is we're not exactly sure where. Like we can generalize and say, well, it's generally simpler features that are on the left, and it's more complex, higher order features that are on the right. But we don't know where. And if you retrain the neural network, it'll be different it'll be different every time. So it won't come out the same way, but it'll achieve very approximately the same purpose in the end. I wanted to contrast this briefly with, like, most of us when we were in school and we learned math, and we learned that, oh, there are these functions and if formulas, and if only we could remember the formula and know how to use it, then we go to our test day and they give us some work problem. We're like, oh yeah, we have to use that formula, and we plug in some values and we get the result. And that was at least how some of math was taught decades ago, and maybe still is. In today's world, we can't figure out the functions for things. So the math is completely turned on its head. It's different. It's okay, well, I know the Y and I know the X, so I'll just get a neural network to figure out what the function is. And that's what we're probably going to have for the rest of our lifetimes until we have quantum computers, is we're going to have these neural nets, and we're going to have all these problems that we don't know how to solve. And so the neural net's going to do it. and it's going to encode all of this information inside of it. And we can, in many cases, use this information that's inside of it for lots of purposes. So that's kind of one of the points that we're going to drive out with this. And this doesn't really matter. And Alan, if I'm murdering any of these topics, feel free to jump in and add something.
I'd like to jump in with a comment.
Sure.
So you might say the rightmost hidden layer, the center node. You might think that this is recognizing furry creatures when in fact it's recognizing that the third pixel from the left down 5 columns is blue, and the 20th pixel to the right down 16 columns is not red, type thing. And we say, oh, if we show all these pictures of creatures, non-furry creatures versus creatures, this thing lights up, and therefore it's recognized furry creatures. It is in fact recognized linguistically, nothing that semantically models to anything that we know of at all. And we almost can't figure out what the heck it recognizes anyway. So my point being that if we rely on neural nets, we are going to get interesting things, but we will never know if it's right, and we'll never understand why.
Yeah, so all great points. And I believe they're all true in the construct of, a given situation. It all depends, okay, on having one. I'll give a famous example. When they first started creating these, was the military paid like $50 million to somebody to create a neural network to recognize tanks in reconnaissance photos. And at the end of it, they got this neural network, and it was recognizing, and I may be messing up some of these details, but it was recognizing all this stuff. And so then they went out and used it in the real world, and it didn't work for anything. And it turns out that all the test data, all the photos were on cloudy days that had tanks in them, and were on sunny days when they didn't. And so what they really did is just trained a neural network to recognize the lighting conditions photographs. So
yeah, and my problem with I use the example in the Google model of self-driving cars is that Google has a huge number of pictures of bicycles running in front of cars, but I'd be surprised if it has a single picture of a hawk dropping a duck into the middle of your windshield, effectively, or in the middle of a camera. That sort of thing.
So so what I will do, the concepts of what I'm saying, okay, are true in the verbal space, and they are true in the visual space, and they are true in other spaces. However, I will give the caveat that the visual space is much less mature in its training. And so we'll just kind of take that and put it aside for now, but it's all true. There are issues, and this is going to evolve. So how can we progress from this? How can we use this? That's where we're going to be headed here, because I want to stay I like to always be practical about this stuff. It's like, how can we use it to make our robots better? If there's not an answer to that, then I don't care for the most part. So, but I do want everybody to realize that essentially this applies to, in my mind, I can't think of any that it doesn't, and all the different model types. So they're all learning these weights. And of course, some of them are a little different in how they do it, how the propagation works, like all the RNNs and LSTMs and the transformer as well do it back through time, and transformers takes it to a whole nother level and adding the attention. But at a high level, where I'm trying to keep it, it's about these weights. And so then what can we do with them? Trying to figure out which, okay. So what do they look like? Well, if we were to get at some of them, well, they just look like a bunch of numbers, because usually when people are doing this stuff, they end up building it with NumPy and TensorFlow and tools like that. And so the easiest thing to do is just to get this stuff. But really what it is, to me, conceptually, it's just a vector. And if you normalize all those to be between, 0 and 1, that's a pretty common practice. You just basically have a bunch of floating point numbers that represent some concept. And so think of it this way, is that, okay, well, maybe there's some model out there that you would find useful. You can give it some concept. And if you could get back this numerical representation of that concept, well, then what could you do with it? Now, how would that be useful? And I think I say we're at this inflection point. Once again, opinion, but it's part of that inflection point, I think, is we have an ability to encode almost anything now. And I think that's important. We'll talk about why. But that's what embeddings look like. So what are some of the ways that they're useful? Well,
Just one quick thing. What does the term embedding mean that you're saying? Embedding is the representation of one of the columns there or one of the nodes?
It's, to me, conceptually, and we're going to get to the limits of my vocabulary and specific knowledge on it. To me, they're just numerical representations or vectors for those weights that were learned by that model with respect to some concept. So
for one of those subarrays, it would be just the weightings of all the input connections to a node.
And there are different ways to use it. I'm using them in a simple way, which is just giving some concept to some model and getting back a numerical representation of that concept. So if I had a concept of red, I could get a vector representation of red that was much more rich than just our straight color definition. So for example, there are libraries that you can download and execute locally that will give you high quality vectors for words. And there are other things that you can download very similar that will give you high quality vectors for an entire sentence.
Okay, I think I understand you.
You want to take it to another level, okay? You can send an entire context, a paragraph, whatever, 8,000 characters, what have you, to ChatGPT, and you can get back a numerical representation of whatever you gave it. So imagine if what you might want to encode. You could take potentially, visual aspects of objects. Like a year or two ago, I was doing some stuff on vision and I was capturing the color signature and all these features about the objects that the robot saw in the house, or the playing cards, or its body parts. It could see its body parts on the ground and recognize them, but it was using old techniques. But it might be possible now to just encode the features about that visual object. And I think this is something maybe that Alan touched on, but encoding that sort of semantically, and then instead of having to build your own model and all that kind of stuff, just give it to someone else's model and get back an encoding for free. So, like ChatGPT will give you embeddings. That's one of the things that their API does. So we'll talk a little bit more about what that means in the rest of this.
So tell me one more time, what is embedding and encoding? I'm getting a little confused there.
Yeah, multimodal, I believe what they're referring to there, they're just, I don't know what you're reading, but multimodal has a lot of different meanings. But with respect to ChatGPT, they're referring to taking in text and an image and giving you, basically cogitating on those two streams at the same time, those two modalities. So this would be like a picture of an open refrigerator and a question, what can I make for breakfast? And by combining those two and giving you a more intelligent response. That's multimodal as I understand it, in the context of ChatGPT. So what it would mean in our robot, it can mean whatever we want it to mean. We can make multimodality mean depth, sonar, localization. In theory, I think a robot might be able to localize just using embeddings. Now, whether that would be computationally efficient is a whole nother question. But is it possible? Probably. But anyway, I'm jumping ahead too much. So
That,
let me.
by the way, is what I'm trying to do with my robot, is that very same thing.
Okay. So in a word space, I want to just try to keep it simple. Like in the verbal, there's enough challenges of just recognizing what a person may be trying to communicate to the robot. And so this little dartboard thing, which once again, this is DALL-E trying to draw a robot playing darts. So you get kind of, it gets funny, peculiar. But you could think of the whole word space as a bunch of dartboards spread on a wall. And as you're trying to capture, and many times you're doing many of these at the same time. So it's like, well, loosely, what's the verb? And loosely, what are the objects that the person's referring to? And loosely, what is the time frame that the person is interested in, And so as people add adjectives and adverbs to their speech, it changes this meaning, and it makes it, things either more white or black or gray. And that's the battle that you're constantly fighting in a thought loop, on a verbal robot that's taking input from humans. And we're getting to where we have just incredible tools for doing this. And so I started using the embeddings more directly recently. And I guess that's what was the catalyst for getting me more excited about them. There's really nothing particularly new at all to what I'm saying here. I could have given this talk, easily 5 years ago, but the difference is where we're at, that inflection point, and what tools we have that we can use. So so we just touched on this briefly, but like custom purposes. So like I have the robot there kind of standing in a spot. You could think of that as like trying to figure out where it's at in space as it's hearing you talk, and it's trying to figure out what it is that you're saying. I think there must be a lot more uses. So I think a lot of this stuff is just like, well, what's our imagination like? What can we imagine translating into something that we can encode? And so nowadays, that translating is easy because we have these transformer models that can be the middleman for us. So we don't need a lot of brains or tools to encode something using ChatGPT. If we can write it down, if we can express it in name value pairs or in some way, some format, we can give it to them and they'll give us this encoding. And it's kind of like a hash code, but a whole lot better, because you can't really compare two hash codes, but you can compare two embeddings to see how close they are. So the principle behind this is basically let me. After you get them is, let me, don't I have something on here about how to use them? Let's see. Okay, here we go. So, recognizing intent at a high level, that's an obvious one. You can calculate the distance, the cosine similarity between two vectors in like one line of code in Python. And that gives you like a measure of how far apart two things are. And this is tremendously useful if you think about in all kinds of verbal contexts. So I talked about like all the different ways that someone could say yes or no as being a really simple case. All the ways people could say in English and how you classify that. Embeddings can do that. Or if I needed to recognize if I wanted to use embeddings to recognize commands, well, all I need is an embedding for all the commands that the robot supports. And then just figure out what the nearest neighbor is whenever someone says something. And if the distance is not too great, then it's very likely that that's their intent, is to do that command. That's a simple case. And then depending on that command, you could get down to the nouns and the objects. Go ahead, James.
So basically I'm following this, but I'm a little puzzled about going from one domain to another with these embeddings. That would seem like you'd have to have the same coordinate system so that your vectors had some meaning. If one of the coordinate systems was Cartesian and the other was radial, even if they're covering the same space in a sense, you couldn't really compare the vectors or translate the vector from one to the other without.
I was going to say something similar in that, given an embedding, looks to me like your use of it is as an array operation. And this works if everybody's agreed what is on the left side of the array. So if you're handing out embeddings from your robot to me, my left side of the array has to agree with what does that mean. So like if it's a string of letters and it's the serialization of a string of letters and everybody agrees on how to represent that, then I can see sharing embeddings and finding the cosine similarity between them. Yeah, that seems like an interesting topic. But if we were doing like object recognition convolutional network, we would have to agree that the left side of the matrix is a 320 by 240, row order matrix that's been normalized in some way and so forth. And then it might work. Does that sound right? Is that also what you're saying, James?
I think so. It occurred to me that one way you could work around it would be if what you're doing was feeding the embedding back to the same model that you got it from originally. If you're storing the result from a time past and giving it back to the very same model that generated it to restore a context, then that might work. Because presumably it still has the same vector space. But
I think they're all good points and questions, and that have to be borne out by testing, for the given use case. It's hard to, I'm so much, embedded in the verbal ones. And so trying it out, using, for example, ChatGPT's encoding system, in a visual context or in some other context, you would be much more likely, I think, to run into those issues that you're talking about. And I find with everything else, for example, that I'm dealing with ChatGPT, you still have to spend a lot of testing around each given use case before it gets right. But having said that, I do think it's kind of like what you described, James. If I had more firsthand experience with that, I could say more confidently. But that you're using vectors all from a common source, and so if you can give it the input in a consistent way And if it's sort of underlying training, semantic scheme, whatever that it uses is capturing enough meaning, like if you try to do this and you try to send it to sentence embeddings library, it may or may not serve your purposes, you know, as opposed to another embedding library. So it does matter which
So if I
model.
understand what you're saying, here'd be an interesting experiment then. So if I understand where you're going with this, you could assume that everybody's using ChatGPT as the processor, some particular version on some particular server and so forth. And if we were to tell everybody, get 100 people in a room and say, speak a 6-word command to tell the robot to open the door, without using the phrase open the door. Okay, something like that. So now we've got 100 people that are trying to express the same concept. And you're saying that if I look at the embeddings from this, you would think that there'd be a good clustering, a good cosine, a small cosine distance between many of these sort of things. Given that speakers have spoken at different rates, they have different timbres in their voices, they're speaking with different accents and all that sort of thing. You're speculating then that there would be a cosine similarity from a wide variety of these things expressing a similar concept, so that when I hand this embedding to somebody else, they could use ChatGPT, they could tell their robot to open the door however way they want, and there'd be some small cosine distance between your embedding and what ChatGPT produced. Is that right?
Yeah, you added some extra steps there. I don't know that they need to be, that any of this needs to have to do with everybody agreeing on anything or any of that.
Okay.
So that part I got a little bit lost on, but it's just that I would think of it more, and maybe this is me, maybe this is not the right way to approach it. It's just how I'm thinking of it is if you're building the bot, that the bot may collect a set of embeddings for some concept, for some use case that's relevant to that bot. And if those embeddings have some underlying relevance to the model that you're getting those embeddings from, then you've got a decent chance that they're going to be useful for your purpose of finding, say, nearest neighbors using, you know, dot product cosine similarity.
I guess
So-
my conditions were around, can you share your embeddings with somebody else? You know, if you're only looking at embeddings in your robot with you speaking, then that's a much more constrained environment. So I guess I'm making assumptions about what it is you're saying. I'm assuming that you're saying is that if we all got together and asked the robot to open the door, that somehow we would come up with a collection of embeddings that we could, as a collective, hand out to each other and say, now just stick this in your robot and say something to it. And if you look at the set of embeddings, and if the cosine distance from at least one in the set is small, then that probably means you should open the door. And if so, my criticism, my extra condition was,
Yeah,
well, my voice is different than your voice, and my accent is different, and so on and so
oh,
forth.
you're talking about the audio part of it.
Yes.
Yeah.
Are you not talking about the audio part of it?
I'm talking about the word part, and the word part at this day and age is trivial.
Oh, so like a textual input type thing?
The thing of the recognizing meaning in sentences,
Okay.
and the cosine similarity between that and then in word vectors and in sentence vectors, I think is, I mean, it's just opinion again, but that it's getting really good.
Okay, so
And
I
now,
went way off the rails, assuming
And-
voice input, but if it's text input, that normalizes, it gets rid of a lot of the dimensions of the input. Okay.
and now we have, you know, ChatGPT adds a whole nother level of context awareness to that. So effectively the entire like conversation that preceded that I'd like a red stripe could be taken into account in that embedding that came back. And so that embedding effectively could end up containing my emotional state, my whatever, how truthful I am, like all kinds of information could end up being in there, but we won't know. So anyway, I'm getting off the rails a little bit with that.
So
Someone said,
this is Alan.
Yeah.
Is it assuming the model is fixed, and therefore it's to a particular release of GPT, and if they release or if they upgrade the end of chat and you knew about it, you have to keep it like a fixed model, right?
the audio was really breaking up. Were you basically pointing out about
I'm
like
sorry.
versions of the model?
Yeah,
Were you-
yeah. My understanding of the embeddings is that they would be dependent on having a fixed model. And the
Yeah,
model
yeah, so-
change underneath you.
I should have, I meant to point that out with Michael's question, but yes, like as soon as someone changed the version of the model, anybody that had cached embeddings against the old version, they couldn't really like move forward with any, they couldn't compare that to any embeddings from any other version or model, I believe.
Yeah, but you
At
could
all.
break those from the equivalent of a test bed for this thing. So you could have, 10,000 test cases to generate the embeddings, right? So when a new model comes out, you just run the test script through it again.
Yeah, and in fact, yeah, and Alan, if you want to look at this at some point too, what I have just as an early test case of a little bit of this is in the graph, which is the memory for the primary memory for my robot. I have, if I add some sort of background information to anything. So for example, I'm going to try to find one. So here's a list of all the services, okay? And so if I go into the serial service, I look and I added this attribute called background right there. You see that? And so what this is just textual information about the serial service. So I could add a bunch of background if I wanted, or make it a paragraph, what have you. And so in this system, I could tie background information to anything. So anything about the robot, I could just say, oh, I'm going to put a little background here. And so then what happens when my robot starts up is it actually reads through all of these backgrounds, finds all of these background edges in the graph, and re-encodes them all. Now, is that computationally efficient? No, it could just remember them because the version's not changing. But it figures out all those vectors and has them. And now if I ask a question of saying, well, how does let me try something. How does your serial service function? Something like that, okay? It can then go and find through nearest neighbor all of the embeddings that are the closest in its whole entire population of embeddings that it knows about to that, and it can add that data to the context that it passes to ChatGPT. So now what ChatGPT is going to receive is it's very likely going to receive this edge, this data, and any other edges that were within a certain distance, or maybe I just did a top 10 type thing. And so now what I would do is I would end up getting back an answer that's not only going to take into account the personality and the other aspects of the robot, but it's also going to take into account the most relevant context local to the bot that I'm aware of, based on embeddings, not based on word matching. So I happen to use the same word here, but I could have said, let's try like I don't know, how does your spinal cord work, and see if that'll, no, I mentioned spinal cord in there. Anyway, let's try it anyway. Spinal cord work. Now, the trouble with mine is my robot, it ends up bringing out more of the personality and less of the context in the answers. So we may or may not get back something that actually pulls. But I have noticed some of the time I get all personality, and some of the times I get specific things that would not have come from ChatGPT that were directly relevant. Like it'll talk about the Arduino or something in its answer. You guys tracking with what I'm saying? So this is basically just a preloader of embeddings for about things specific to the robot that you can then add to your ChatGPT prompts so that it takes that information into account when it gets back an answer. And let me do this in a different way before I'll just.
What do you have for sequential communication?
How does your, something like that. And, once again, we're probably just going to get a pithy remark. It probably won't have anything to do with this edge.
Well, it's pretty different from a human spinal cord, but it's the backbone of my brain. It transmits all the messages from my microcontroller and makes sure everything stays in sync.
So we did get seemingly that got taken into account this time around. It's more specific. And so this is what I mean by like increasing the relevance of the robot. And I don't mean just verbally, this just happens to be what we're concentrating on, but it's an example, a real example of using embeddings. And so, and in this case, I'm not even encoding them with ChatGPT. I'm encoding them with a free library called, anyway, it encodes sentences. So it captures the meaning of a sentence in, I'm trying to remember, is it 384 dimensions, I think? So does that use case make sense? So you have a brain, you have like some background information on different things, or you could pull all the comments out of the code, or like there's all kinds of things you could do. You could get ChatGPT to summarize your own code and then encode that and have that around as context that you then added, so that if you ask the robot a question very specifically, like what's wrong with this function, and it might be able to know exactly what function you're talking about. I don't know, I'm just pulling use cases out of my.
So if you are saying that you have software that'll take a sentence, convert it into a vector of 360 numbers, and then given some other random sentence that converts into a different 360 vector, that you can find a cosine similarity, find the smallest distance, and say it probably is talking about this, then yes, I understand.
You got it exactly. I couldn't have said it better. That was a perfect summation. And so you don't know, like I think even the way you said it there at the end about not knowing, that was well said, because what you have to do then, in this case, what I'm doing to solve that part of the problem is I just pick n number of those and add them into whatever it is that I'm already sending to ChatGPT in the background. And then it can figure out whether that individual piece of information or some other piece of information that was vectorally close, it is truly relevant.
Mm-hmm.
So this is like a way to do sort of a first pass relevance to give something, because your alternative, if you want the robot to have these answers, there's two alternatives. Either you have to pass everything that you know about the robot and that it knows about itself and all the state all the time, and you're gonna go broke paying your bill, for one. And then your alternative, the other alternative, so that's like passing everything up front, is you can create a plugin that hooks up so that ChatGPT can call your API to get data that it needs. I have not tried that. I've heard some of the people on the site have talked about that. And I think we'll end up using that too before the year's out. But I think this is called loosely semantic similarity. Like if you're using this type of vector technique in the verbal space, it's called that, but it's really just this, cosine similarity or dot product if the vectors are normalized, which many of them are. So you just, like with NumPy, it's just like, MP dot blah 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 and the two vectors, and you have your number. And so you end up just having to either remember that in memory, create a list or a dictionary that holds these, and then you're searching through that list, of things to find the stuff that you're interested in, or you need a vector database of some kind. I wrote a little bit about this recently because their vector databases, I think, are becoming a big deal and becoming more common. And there's one library that I found that was supposed to add vector search capabilities to Python, but I could not get it to install on my machine. So if anybody sees that, and if they're able to get it to work on their machine, I'd really like to know how you did it. Because anyway, I'd like to use that, because then you could just not have to hold a lot of the stuff around in memory.
What is the
so
name of that package?
I'm not doing this on a large scale yet. I will look that up when this is over and post that in the chat. I don't recall off the top of my head, but it was in the, I wrote about this in the, I think in that big GPT for all thread. I think I did a thing on, so I'll track that down and get it to you though.
I think one of the vector database that's getting popular is the Pinecone, Pinecone, Pinecone. I guess that also has a Python library to.
Hey, Martin.
Yeah.
Sorry to interrupt, but Martin, I got to bail here. I'm sorry, I got to take off early. Thank you for your presentation. I'll catch up with you later in the week then.
Okay, I think we about hit a good stopping point for that topic. Pretty close. So, but do you want to hand the thing over to me?
Yeah. I'll make you the boss.
Okay.
The Zoominator person plus make host. There we go. You want to make host? Yes, I do. There we go. You should be host now. Are you host?
I don't know. I'm still here, so I feel hosty.
Hover over your thing and see if it says make somebody else host. See if you you have security now, so that's good. You should be good, Martin. If not, call me.
Yeah. Okay.
I'm leaving.
Right,
hopefully the meeting won't die.
If we get kicked off, dial back in a minute, everybody.
Yeah, just call me, Martin, if we get kicked off.
All right.
Okay.
So
it's good seeing you all. So
Michael, you described it very well. It's not like a crazy advanced topic or anything, but I think it's how we can use it that is maybe unexplored territory. So it's probably mathematically it's a simple concept, but I think it's until recently. I mean, yeah, there's more, but I'm just going to oversimplify things and say, well, all we really had were in the verbal space anyway. We had some word vectors that maybe weren't that great. And we've had various iterations of those. And then we had Word to Vec. And I'm trying to remember if that was 300 or 600 or both. A couple versions of that. And then BERT came along and they had some embeddings. But I feel like that Chat GPT offering an embeddings endpoint, now that from what I see is like 1500 plus vector dimensions to those.
But just curious if you have yet run an experiment to see if those embeddings do have any cosine similarity, given a wide variety of inputs that are trying to express the same thing.
So in full disclosure, I have not on that one, because what I tried at the moment was the smaller ones. So I've been happy so far with the sentence ones.
Okay.
And I think for a lot of my use cases of and I don't have a whole lot of time because I've been concentrating on getting the robot to pick things up and put them down and try to build stuff. And I'm moving toward the goal of getting it to plan and then implement that plan. So, do something that way. And Alan's also pursuing that problem as well. So I'm hoping we can help.
Thomas in his discussions, it seems like he's looking for ChatGPT and other to build a companion, which, is not of interest to me, but, something that produces actionable items that is of interest to me. So if I could use this.
So I'm on the actionable front, but on the other front, it's also, or there's a middle ground that's also useful, which is if your robot's going to be actionable and you're going to have to problem solve all the time, it's useful to have your robot be able to self-diagnose or self-introspect, like be able to ask it questions and get back answers. And so like for me, I really like the ability simply to be able to say, well, if I'm wondering what's going on inside, well, what, is your, whatever it is, I should have said drive state, it's not going to match, but with a semantic similarity that would have matched, because it probably would have figured out.
My drive state is stopped.
So being able to do that, but then also being able to get into like, well, how does this work and what is going on with this? And so I think that's the degree to which I'm interested in it. Now, that's time consuming in the sense of where does that data come from? And you have to go in there and put that in. And so that's where, like, I do think it's interesting, the idea possibly of taking, I don't know if you saw it, but a few weeks ago, I think one of the last meetings, I did one where ChatGPT, I asked ChatGPT a question about my code, about a particular module, and it summarized it. Here, we'll just do it again. Hopefully it'll work, but how does haven't tried this in a couple weeks, so hopefully I didn't do anything to break it. Always turning features on and off.
Oh, my verbal service is the life of the party. It decides when to chime in and entertains everyone with jokes and stories. It's like having a stand-up comedian in my brain.
All right, I got to be more specific. How does your verbal, trying to remember, maybe I'll try mine, maybe I'll try code work.
Oh, it's all just fun and games. My verbal code uses some pretty cool technology like NLP pattern recognition and language models to understand and execute commands. But let's not forget the most important ingredient, my awesome sense of humor.
So when I listen to what you're saying, I wonder, my problem is I'm old. So, I started back in the days of kerosene computers, and I still think of things in terms of Noel Simon and Shaw's general purpose solver and Marvin Minsky's perceptrons. And I remember the old block world where the monkey tries to get something by stacking blocks, gets a banana, stuff. So the problem solver had to have some concept of a thing it was trying to accomplish and the things that had to accomplish the task. So this thing would be wonderful if you told it to fetch the beer and, you know, it discovered that, you know, the cat was sleeping in front of one of the passages and thought, oh, you know, I could, you know, scare the cat away, or I could try a different passage to get to where I want, and had some way of choosing some alternate path and then backtracking if the alternate path didn't work and so forth.
You watching?
I don't know.
Can't remember where I left the beer, but oh, it's gonna find it. Let's hope. First time I've ever put it on the table in a meeting. Don't fail me now.
So what is this doing?
Nope, it messed up. One of those bugs. Here, we'll try it again. We're gonna put it over here. Down. Okay, so we're putting it down.
Uh-huh.
Now we're going to pick it up again. The picking up off of a table thing, I still got to work on. Pick up the silver bullet. See, I would like to use semantic similarity in that so that it's recognizing the connection between the silver cylinder and the beer, which it did.
Yes.
It did get there.
Is this part of your Wednesday talk?
Yeah, yeah. And so now well, we could do put it on the purple block. It's a little bit off top, but hey, I think this was supposed to be dessert anyway, to some extent, so we're all good. And the one that I really want to.
But I was picking up on what I thought you were saying about you wanted to use this thing to solve problems. I'm not sure I understood what you meant by that.
Yeah, so this is not gonna work, what I'm about to do, but I can kind of show you. In fact, let me pull up an exchange. This was my first attempt at something like that as far as a verbal exchange or a prompt. I've since changed the prompt, but I'm gonna just show you an example that I thought was positive, but it's in practice, I've been having challenges, and I'm hoping to get Alan's help figuring that out. He's been looking at it too. So this is what I gave ChatGPT as a prompt. You're a robot that can drive around and has an arm that can grab objects. And I just gave it some rules, and then I gave it some context about where objects were and a little bit about each object.
Mm-hmm.
And that went on for a bit. And then let me see how it kind of wraps that up. Okay, so I'm going to hit return just so we can divide this up into the conceptual parts. So we have kind of the identity, and then sort of constraints, and then I have sort of, this is the ask of what I want it to do.
Mm-hmm.
So you could think of this next part as being what the user actually said. Because what I do is I test these out using the website first. And then when I start to get to a prompt that I think is useful, then I go and I move that into some code and I start to put some structure around it so that the context is coming in from the code, you know, like getting it to actually work. And then it gives some capabilities.
And how does
there.
it understand what go means and pick means?
And that it just kind of already knew from its basic semantic
So you're getting that for free from ChatGPT?
from knowledge. And then this was what it produced. Okay.
Oh,
As its result. And so because Ava, for example, already processes basically paragraphs, then I just need to make sure that there's a good enough match between the sentences that it produces semantically, that they're close enough. I could use semantic, what I call it, semantic search. I could use semantic search here to interpret those responses and execute them. But for me, I just have the NLP mostly doing this. And so most of these sentences are actually executable. Like if I say go to the den, well, it's going to go to the den. If there's any doubt, then let's just go to the den.
but you're saying ChatGPT understands the implications of go to the den, changing its position and knowing the locality of objects from the new position, such?
I can't say what it understands or doesn't. It's just kind of like, do you get a decent,
Yeah.
do you get a response back that serves your purpose?
Well, that's kind of what I mean, yeah. But
Yeah,
you're
yeah,
doing this
yeah.
for free from ChatGPT.
My bad for, that is understanding. If something can discern your intent and then give you the response that makes sense from it, then
Right.
I'm kind of like the Turing. If it can
Right.
do what it needs to do, then it solved the problem. So let me go through your question again. Then can it understand the constraints and the location and space? I think that's, you asked that.
When it wants to put the silver bullet on the red block and the block's 2 rooms away, without you telling it, it knows that it needs to go 2 rooms away before it can do that?
So let me find the output again.
Well, I think, why don't you show the prompt again? I think that's sort of what he's asking about.
Yeah,
I didn't see anything in the prompt that indicated that it knew what the implications were of going to a room or picking something up.
figure out why one of them won't show up. Is it behind?
Well, picking something up and going to another room has an implication that I still have the object with me and the object is nearby me, and you didn't describe that in the prompt that I saw.
Okay, so let's see. What did we give it?
If you pick an object up, what does it say?
Somehow I messed up my formatting that I did. So I'm just gonna, so you're looking for, we told it where stuff was in this, but actually we didn't need to. In my case, my robot already knows where everything is. So it's actually kind of superfluous planning, really.
Yes, but you didn't, like I say, you did not say that when you pick something up and go somewhere else, that object is still proximal to you. That's not something you put in your prompt, right? It just understood that from its built-in, transformer predictor.
Yeah, no, so this was, let me see. So you have the arm, you can pick up, you can only pick up one object at a time. Okay. So that's kind of where we're implying if you pick it up. I have another prompt where I get more specific about the rules on this. And I say, well, you can pick it up and you have to put something down before you can pick something up and that type of thing. So this is all like hello world kind of stuff.
Yeah.
In a planning sense, this was my very first sticking a toe in the water. And so if I were to try this in the actual sim, it's not going to work, because what I'm finding now is my prompts aren't the same as this one. And so the results coming out the other side, I'm also getting a lot of bad plans. So I haven't figured out yet, like the proper kind of way to describe this problem such that I get a reliable result. But I was trying things like build a tower out of 3 blocks, or build something that looks like a lamp, you know, or
Right.
build an orange and a blue house, stuff like that. That's as far as I've gotten.
Right. But you haven't
and,
told it what the characteristics of a tower are. You are assuming,
no,
yeah, right.
no, I have not. And so, but I also haven't gotten any particularly good results out of it. Sometimes it'll grab blocks and it'll move it from one room to another, and then it won't use that block. It'll use something else and put it on. And I think, oh, I don't like that. But then I go, well, what would a 2-year-old do? And I haven't had any 2-year-olds, but I figure, gosh, if I was a parent and they were doing that, I'd be like, yeah, that's great. I mean, what's wrong? They changed their mind, you know, so, you know, like it does seem reasonable and human, you know, in a sense, but there is a lot of work to describe the problem.
Yeah,
Such
but
that
you wouldn't want to feed all the, you know, RDP triples in the world into this thing so that it understood all this stuff.
No, and I think the RDP triples are already effectively reflected in its semantic
Yeah,
kind of
that's what
understanding the world. We're going to see one of these plans.
it's
shoot
not
by.
reliably reflected, it sounds like.
So I'm gonna scroll back and see it. So let's try one of these, like
So,
build a tower out of 3 blocks.
so one of Michael's earlier questions that started this off was, what if there's a cat on the floor that wasn't there during
Holding the
training?
small red block.
Have
In the
you
medium
thought
green block.
thought of a way that so your initial prompt, you know, go do this, this, and this, doesn't include something,
Holding a
an error
large blue
condition, a
block.
cat,
Hey,
how to work
James,
with that?
Large blue block on top of the medium green block.
hold on just a minute. So what's happening
Put
here
the small
is
red block on top of the large blue block.
Ava is attempting to execute the plan of building that tower.
Right,
So it's not working yet, but I thought hey, trying is
sounded
better
like it
than.
was close. Didn't it just
Yeah.
set the blue block on the green and then the red block on the blue?
So I want to go back and see if I can find the plan. So it looks like we got to some stage. Let's see. Okay, so here's where it first came back, and this is just my code spitting out some comments to the command prompt. So these were the instructions that came back, which are probably dumb, but go to the den to pick up the small red block. See, that's interesting. Okay. Stay holding. So it's telling, so that's, she did speak. She did pick up and respond to these things,
Mhm.
and she was moving around a little bit. But it's like using a lot more prepositions than I might perhaps want it to.
So here it's holding 3 objects at a time.
Yeah. So there's work to do, but that's one of the business problems that I'm interested in.
Yeah, but it did solve the problem. Maybe not with the constraints you wanted, but it's logically complete.
Yeah, I mean, it was it did come back with instructions, whether they're sensical or not, you know,
Yeah.
is, yeah, doubtful, but yeah, and so for me, there's just kind of these like kind of gearing issues of getting Ava to be geared to ChatGPT and vice versa, because it's kind of like it's two verbal engines trying to figure out how to work together. I know I'm anthropomorphizing there. It's me trying to figure out how to get them to work together, and get the bugs.
See, I could see you solving this by every time it solves one of these things, you say, oh, I see your problems. You didn't understand this. Well, I'll add that list of knowledge to my prompt and try it again. But it's like you say, can you afford to, train your 2-year-old to become a 3-year-old and have a 2-year-old's knowledge to do something by adding more, don't do that, do this instead, to it. And having it, reprocessed.
Yeah.
And
Yeah, I think we're going to get better at writing prompts and constraints. And Alan, you sent out that thing on the Microsoft paper, and I think that's relevant here to tell people a little bit about, because well, are you there, Alan?
Yes, I'm here. I'm here.
The paper about how, yeah.
No, go ahead. Go ahead. You could probably talk about it better.
Well, yeah, I haven't slept much lately, so give it a go, and I'm gonna.
Oh, what did you want me to answer about the Microsoft
well,
paper?
I mean, if you just wanted to explain their approach to it, I need to make a pit stop real fast. If you guys can carry on without me for a minute.
Okay.
so Alan, is there a Microsoft paper that talks about,
Yeah, I sent
adding
it
data?
out a couple times. I sent it out group a couple times.
Sorry that
It was
I haven't followed this group much, and I'm sorry if I'm dragging you down a rat's nest there.
so yeah. Give me a second.
And your audio's dropping out quite a bit.
Yeah, that was get Martin to answer to you. I'm having trouble with connectivity today.
Yeah, I find sometimes if you just talk louder and close to the mic, it solves the codec issue.
I suspect that's a Wi-Fi problem or a Ethernet problem or something.
Could be.
The smearing, the sound smearing, I think is bandwidth issue or something.
Yeah, it's definitely the Wi-Fi. Okay, it's called the it's this. Oh no, that's the wrong one. Wrong date.
So we covered verbal. We kind of sidelined some visual stuff. Location, other space vector spaces.
So if I could just jump forward and jump back so I understand the
Sure.
motivation. Are you going to tell us that this is promising and it's working to a good degree for you?
You're talking about the planning aspect?
Whatever it is you're trying to do with all of this here, yeah. Is the using of these embedded and doing similarity between embeddings. I assume that's the focus of your talk here.
And you're asking me if am I going to report back if it works?
No, are you believing it is going to work pretty well?
Oh, well, I mean, I think it just depends on each given context or use case. So I'm reasonably happy just using NLP for most of the command stuff.
Mhm.
So I don't know if I'll want to convert over to using embeddings in there as a substitute for or in addition to. I like to try to do things without having to go to a remote model. So it would be beneficial. So if I'm doing an honest assessment of my own work, then hey, it's got some aspects of it that are good. Like if I grade on a curve, it's better than some other people's verbal stuff, but it objectively speaking, it's still brittle. I tend to use only a certain number of words for go or for fetch or grab or all these different things. And so it's not a lot of work for me to just add that into my repository if there's another verb I like to use. But if you were building a robot that you were trying to sell, you would absolutely probably want to go with vector embeddings, because you would get that other people's ways of communicating the same idea.
Even if you just did sentiment analysis. So thinking about the robot that is just in a restaurant and is just, delivering food from the kitchen to the customer. And the customer is getting irate, and the robot needs to switch between the customer is happy and my algorithms are more or less okay, versus the customer is now in the asshole mode and I need to switch to my pedantic mode, and
Right.
say, you didn't tell me to move 1 foot to the right, so I only moved 9 inches, be specific.
So that's, yeah, I mean, that was difficult to do a few years ago, and now it's very doable. Like for me, where that would fall in the thing is kind of what since I'm only detecting it verbally, I'm not talking about visual recognition that someone's angry,
Mhm.
but by like detecting if they're angry by how they're communicating.
Mhm.
You can do that with ChatGPT. And that's kind of what I'm calling this tone thing here. And so you can deduce whether someone's being humorous or sarcastic or this or that and the other, and then feedback. And that's, I'm already just finding that very useful, and it's already surprised me, because, like at times I'm thinking the robot's going to be in its default behavior, but all of a sudden it's being different. It's because I was being something.
Mm.
So I think that's an interesting realm, although, yeah, on the other hand, you can get, you can go, how is it you put it? Some people just want to build a big chat bot, and that's like, years of your life you can't have back if you get sucked into that rabbit hole, because I've been there.
Yeah, I just
So I
wondered how many years of your life is this going to get you sucked into? I mean, frankly, Martin, every time I listen to one of your lectures, I'm just amazed and wonder how many lifetimes do you really have that you've put into this? Because you're doing far more productivity in your work than I am. I'm still trying to get my robot to fetch a beer, and I can't get it to go down the hallway without smacking into the walls. And I listened to this stuff, and I said, God, I'd love to have this visualization and your models of doing things here, but I can't figure out why path planning doesn't work right. And it's like,
Well,
how much of my life do I want to spend reading, Steve Masinski's code and to figure out why he's doing this?
Did you get it to go down the hallway?
Most of the time it does, but my latest robot, as soon as I tell it to move forward 1 meter ahead, the first thing it does is, and it's in a narrow hallway. That's the problem with my robot.
Yeah.
First thing it does is go to the left and smack into the wall. And it's like, why did you even go to the left? And it will not tell me why it did what it did.
Well, I was gonna give you kudos, when in your example you gave, because I'm like, there's a huge difference between getting something to go down a hallway, a real hallway versus a virtual hallway.
Yes.
So, I don't,
Oh yeah, these things work perfectly in simulation. Yeah.
I tried with this one to make it indicative of real world challenges in the way that I was like figuring out the sensors and other things, but yeah, it's still it's never the real world. So yeah, it's a good point. I had luck before trying to use force field algorithm in that type of thing. So if you just have all that around, the bot will try to steer towards the kind of easy space in between.
Well, Ross gives you that automatically. It has a, what is it called? It builds a gradient field around all your obstacles, and then tries to find the least cost. And there's different algorithms for, do you want me to, plot a path down the center of the least cost, or do you want me to stay close to the walls, just minimum distance? You want me to find the fastest way, the safest way, the slowest way, all these different trade-off decisions on it.
Gotcha.
But yeah, I'm using ROS, and ROS fundamentally doesn't understand that Unix as a preemptive multiprocessor operating system has a real hard time guaranteeing latency between sensors and algorithms that use the sensors, particularly if you're talking multiple computers talking to each other. So, and
Well, I
that's-
haven't seen anything recently, but they were doing some work in that area, weren't they?
there is Unix available that has more, hard schedulers in them, but I'm not using those.
I thought ROS itself was starting to add some more real-time aware capabilities or something. I'm not quite. It's been a while since I saw it, but I thought
I guess
most
I'm-
recent ROS World had something.
Yeah.
So explain to the layperson why the real-time characteristic is important for,
So in a moving robot, so the way, I don't know if you know how the way these localization and path planner things work, but like the AMC algorithm, the way it works is it tries to figure out where you are in the world, and then you move the robot. And after some small time difference, it takes a look at all your sensors. It speculates like 5,000 places that you might be. And it says, given the sensor readings that I have, which of these 5,000 predicted places you could be is most likely where the robot is. But the problem is the sonar. So I've got 4 sonars, 8 time of flight, and 2 LiDARs. All of those things are sending data at different points in times while the robot is moving. So does the sonar reading that came, 10 milliseconds ago make any sense? Because it's not predicting what the sensor reading should be. It's just taking the sensor reading as you gave it. And its only parameter is how long ago will you accept a sensor reading to be put into my calculation? So if the sensors are more than 30 milliseconds old, it'll reject it, and you'll get an error message saying, I've ignored this sonar sensor because it's too old. But it doesn't try to predict the path of the robot and adjust the sensor for what an obstacle might be out there and so forth. So you're constantly up against loop rates and sensor rates. How fast can I do the path planning loop? How fast are the sensors coming in? And you're relying on a highly accurate clock between all the computers involved. So if those things get skewed with each other, the whole thing falls apart.
and is it all about the SLAM?
Yes.
So are there other scenarios where the real time is really important?
But I don't think of any right offhand. But the
Yeah.
AMCL, the localization part, which usually happens, I think AMCL probably only happens when you're building a map. And I think the SLAM toolbox without AMCL is what happened if you have a map in hand and it's just trying to localize.
Going to be anything as well, I suppose, that's based on like using, delta time.
Yeah.
In really small quantity. Like I'm simulating drive kinematics inside my simulator doing that. And so if I get too much stuff going on, open too many windows, and the vision loops running at the same time, so there's YOLO and all this other stuff, then it starts to throw off the steering,
So
because
you
it's,
should have this problem already, that even using LiDAR, once the LiDAR, so the LiDAR, just gathers a point at 0 degrees, and the robot's moving out, gathers a point at 1 degree, but the robot isn't where it was before. So that same wall is now being reported at a different distance because the robot has moved. And at 2 degrees, that wall ahead of you is now at a different distance, even though the wall is consistently at the same distance. So you are limited by how fast you can move your robot before the figures become too invalid. Even though everything's reporting properly, you're only getting a report once every rotation of the LiDAR. But every one of those degrees is at a different point in time, and the robot has been moving that whole time.
So does the SLAM just get more inaccurate in that, or does it just fall apart and not really work?
So mostly SLAM, like Steve Masinski's SLAM toolbox, they go and, they create a map, you move, it tries to figure out what the map is, and then it says that it's very likely that the map I had is somewhat truthful. And so whatever I get, I'm going to readjust the position of all those sensors so that it makes the most sense relative to the map I had a second ago. So you'll see this when like Camp drives around all the time. You see, you get these crazy maps, and then when he stops, everything sort of snaps into position. That's it, trying to readjust the data to make more sense. It assumes that, that there's some sense of lines being in a line and things like that. So that's all part of it, trying to make sense of the world thing. But if you go too fast or the sensors generate too much bad data, you will see even in Camp's thing, all of a sudden the map just goes crazy. It no longer, you'll get two views of the wall that are 30 degrees apart from each other, and it no longer can figure out which view of the wall makes sense. And that's when the recovery behavior comes in. So the recovery behavior has part of the behavior tree says, well, the first thing I'm going to do is spin around in place. And, I will, since a robot is no longer moving linearly, only rotationally, all the distances I get should be a lot more sensible. And, the rotation typically happens in a slow rotation and so forth. But if you run ROS, you'll see that even if you move forward, you'll see that the wall ahead of you, depending upon how accurate you have modeled your robot, the wheels, the wheel diameter and your feedback from your pit loops and all that sort of thing, you'll see the LiDAR wall jump slightly ahead or fall slightly behind, and then it'll catch up. If it has enough compute time, it'll make sense of it all and so forth. But it relies on a lot of things. So I don't use wheel odometry in my robot. I use visual odometry. So I use, the T265 cameras, and they are a hell of a lot more accurate than wheel odometry, which is typically only good for a few feet. And then it's so wildly off. It's like, why do you even bother with it anymore?
I also use that camera without the wheel odometry. It looks like you could do both.
Yeah, the wheel odometry, if you give it, is supposed to solve the captured robot problem, where you pick the robot up and just physically move it. Although I haven't figured out that it does. I'm using it without the wheel odometry because I haven't figured out that adding the wheel odometry, which is just adding more to the Kalman filter, makes it any more accurate.
Yeah, I would like to come up with some solution so that I did not have to use that camera, but I don't know what it is yet. I've been wondering.
The camera works pretty well, and again, what Intel told me was point the camera upward a bit, because the things that the robot sees above are typically perfect for doing the localization. It sees seams between walls and ceilings. It sees vertical things between, cabinets and ceilings. And those are great features to figure out where you are on. What you don't want to see is be looking straight ahead of you at a bookcase with a lot of books in it, and I can't figure out where the hell are the lines between the books. It's noisy data and it's hard to discern.
Have you ever seen my Scout robot that's black?
No.
Okay. I'll just show you.
Hi, my name is Martin, and this is my demonstration of my latest robot.
What was that?
You.
Alan?
Yeah, go ahead. Show your robot first. I thought I was going to take a.
Okay. Anyway, the point was going to be that this robot, what it was the smallest robot that I could build that had a T265 and a PC and all the sensors to do. Basically, it can do everything that my big robot can do, except it doesn't have arms and it can't pick anything up. But it actually has a more ideal sensor configuration. You see this thing on the head?
Yep.
It's got a depth cam facing forward on the edge, but on the top of it, you can't see it in this angle. It let me show you another shot. I'm gonna close. See if I can find a good one of this.
While you're doing that, let me throw out that I was using April tags with an upward facing Raspi cam. And I put April tags about every like 2 meters on my ceiling so that the robot could always see at least 3 of them. There's software that will build a map for you. If you just drive around and you tell it that this first April tag is at 000, and you just drive around, it'll figure out where all the April tags are relative to it. And it was fairly accurate. But the problem is I don't want to have April tags pasted all over the ceiling in my house.
Yeah, I think it was an elaborate way of agreeing with you that having the camera facing up, especially on a short robot, is the best configuration. And see, this one, it can lean it, so and then it can really get a sense, depending if it needs to, by that tilt is actually bringing this fisheye camera. I think you get the idea.
Yeah.
To where it can see what's in front more.
So
In this case, go ahead.
I was going to say my T265 does have a failure path. If I, come driving into the kitchen and then drive up the narrow path of the peninsula between the sink and the stove, it doesn't have the right amount of feature-rich sensor data, and it gets the odometry wrong. And as soon as I make a turn at the ends of the peninsula, it fails almost 100% of the time.
Yeah. I think, Alan, you had something you wanted to say. I didn't really intend on showing any details.
Could you guys check that? If I sent the name of the that you search for, and also GitHub is the same as the ChatGPT robot manipulation prompts. That's the paper that you were referring to earlier about Microsoft, their prompts.
Gotcha.
So is it in that? Did it make it to the chat?
Yes.
Yeah.
Okay,
Yeah,
so
thank you.
You can do a Google search on it and you should be able to, it's worth reading.
Yeah, I see the fetch a beer sample here. All right, looks like an interesting paper. I'll take a look at this. Thanks.
Well, we're down to 3. I was going to ask you a question, but we can save it for another time. But since we have some Ross people in the group, I would be really curious to find out, since you've seen a little bit of the verbal stuff now, and you've obviously seen a lot of the Ross stuff, how you'd end up sort of comparing or contrasting, or, positives and negatives of Ross, or where you see Ross going in that space, or any of that.
Well, to me, they're just solving different aspects of the problem. It's up to you to merge the things. I use Ross because it has all these modules for like planning and using behavior trees to figure out, how to go from one place to another and what to do about. Yeah, I don't know if you saw my talk on behavior trees from a couple of years ago. So I I've spent a lot of time trying to figure out how to use behavior trees and trying to figure out if they're worthwhile. And it's a pretty nice little technology.
Is that recorded?
Yes.
Okay. So I will, I need to go and see that because that's a gap in my knowledge that I'd like to fill.
Yeah, so I was showing you how you could use behavior trees to, for instance, just follow the walls of a room, sort of thing. Do it. So build a patrol bot that'll roam around your house and so forth. And you know what? The thing about behavior trees, if you design it with reactive programming, it automatically handles. It sort of looks at everything all at once because it executes the whole behavior tree every tick. So if you've got a thing in there that says, if my robot doesn't have enough charge or is getting near where I only have enough charge to get back to the charging station, then I need to abandon all hope for what I'm doing, you know, switch over to a tree that says, you know, get me back to the charging station. And then I can, you know, backwalk, you know, and get back to my goal of where I was, you know, trying to patrol around the house from where I left off, sort of thing. You know, and my whole thing about my robot the last year or so is getting into the reliability and safety of a robot. So my robot was constantly smacking into my, you know, $1,500 rocker. And I've got a crowded house with narrow pathways for this robot to get into, and it doesn't reliably find little things like little legs on a rocking chair and so forth, and reliably find, you know, can I wend my way underneath the kitchen table, and is that really a kitchen chair in a way, sort of thing. And if you watch the old NASA challenge, the sample fetch retrieval challenge from years ago, that was fascinating because they were simulating. You landed on a planet, you had to find these rocks on the surface, bring them back to the platform. And there was a $1 million prize for people to solve this thing. And over 5 years, nobody could solve this thing. And every year there was on order of a dozen robots that showed up to solve this. And half of those robots would not start up. You know, they brought them out on a forklift, stuck it on the platform. NASA had your paper written instructions about what buttons to push to start the robot. Half of them would not start up. So that tells you something about where we are in the state of technology. Of the ones that started up, almost none of them made it off the platform. The ones that made it off the platform, oftentimes they got hung up by running into a guy wire off from a telephone pole, running into a ditch and falling over. One of them caught fire a couple of years in a row after traveling a small distance. One of them, I think, ran into the lake, couldn't detect the orange fencing to tell it to stay out of the lake. You know, once they got to found a rock, you know, there was one really nice robot that really got there, and every time it looked down to find the rock and then moved forward to grab it, the rock disappeared from its sensors. So the rock is gone. What do? Oh, I'll back up. Oh, there's the rock. Let me go get it. The rock is gone. You know, grabbed the rock. It couldn't put it in the right case and the thing. And if it found one rock, then they had a platform that rotated around because you couldn't have rocks touch each other. You know, the thing would jam. You know, it was just one problem after another. I said, no one solved this thing. And so I'm trying to think that if I want to have a robot that all I want it to be able to do is just classically fetch me a beer or something equivalent to that. You know, I need to have a robot that will reliably start up, know where it is, know where it wants to go, and just go from here to there. And it needs to be able to do that 100 times in a row without fail. You know, and I'm always commenting that, you know, our table bot challenges and our homebrew robotics, and more or less 20 years I've been associated doing robots with this group, nobody has done this well. You know, they all rely on the robot being hand put on there, facing, you know, perpendicular to one of the sides of the table, and it goes back and forward once, but it won't do it reliably 100 times in a row. You know, so I'm fascinated by all this verbal stuff, but I'm just trying to get my robot to go down the hallway 100 times in a row, you know, type thing. And I'm having endless problems doing that.
Yeah, and I mean, you touched on several big things there, but it's like to me, this battle between simplicity and complexity and chaos is a constant one.
Mhm.
And then so then I think the verbal can initially solve a lot of that, because all of a sudden you can start to have sort of the idea of having a conscious stream of thought.
Mhm.
So your robot can do things unconsciously, but then carry on its own kind of thought or narrative. But even there, it's like my own verbal stuff that I started for this code base, it actually looked really clean like 6 months ago or something, but then as you start adding more stuff to it,
Yeah.
then all of a sudden you're like, then you're, when you find yourself trying to figure out how your own stuff works, and you're like, what is this doing? Like, who wrote all this? How in the world did I find time to write all this? And how, and it's like, what happened to the elegance, But
Well, like you, probably like you, every time my robot gets, decays from all the experiments, all that, I build another robot, starting out with what I've learned from the last one. So this robot in my background picture is Raven. So I started out with Alice. I'm on Raven, and every time my robot starts with the next letter of the alphabet. So that's where I am.
Yeah. Yeah, and I don't know if verbal is going to give you more reliability or less. That's a tough one too.
Well, there's also the problem that now I'm just about to turn 73, and I'm limited by how fast I can program and how fast I can build. There aren't two people working on Raven. There aren't two people working on the same robot in our robot club out of 1,000 members, as far as I can tell. So I have to do everything myself, and you have to decide, where do you want to spend your time now?
Yeah, it's so true. I don't know why I do a lot of the things that I do, but then
It's impressive.
you get up every day and you think about, well, what am I excited to do? And then you end up doing that.
Yep.
Until you can come up with a better alternative, I guess. So for me, I've always, and thanks for those words, but yeah, it's I get drawn just to anything that's a challenge, so anything less than that is boring. So I don't know, so to me, robotics is challenging. Because if it's not challenging, then you're just not trying to do enough. So
when I give talks on robots, the title of my talk is "Everything About Robots is Hard." And I tell people there's nothing about robots that works easily. You can't put a screw in a piece of metal and think that screw is going to stay there, a week from now. If you have a computer that tells the motor to turn, it doesn't mean the motor moved at all. If the motor moved, it doesn't mean the wheel moved. If the wheel moved, it doesn't mean the robot moved. And I can guarantee you, if the robot moved, it did not go where you think it should have gone. Everything about, you can't see here, but I've had to create PC boards just to get around problems with DuPont connectors, those little pin connectors you see on Raspberry Pis. Those things just fall apart all the time. They're highly unreliable, particularly in a vibrating environment.
So what kind do you use?
Oh, so my motor controller is a RoboClaw, so it's got a pin header like that. And so I now have a PC board that has the mating pin connector that clamps down there. So now I have the advantage of all of those things gripping at once. And then I'm designing a piece of plastic that wraparounds the whole thing and clamps my PC board down onto the RoboClaw on there. That still doesn't solve the problem about, it's a very low surface area connection between those things. And eventually, those things will vibrate away. But my solution to this, so the RoboClaw does not fail safe. So the RoboClaw has multiple ways of telling the motor to move and has a very advanced command set. So my command set tells it what is the acceleration ramp how fast I want to go, how long you're allowed to go at that, but what, unless another command comes in. And if you don't get another command, here's the deceleration ramp. That's one command I can issue to the roboclaw. So the roboclaw does its PID loop by looking at the encoders coming in on this thing. If the encoder connection fails, the motors go into high-speed mode. They don't shut down. It just says, oh, I'm not getting the PID response I expected. I need to go faster to get to the rate of acceleration or speed that I want to be at. So I have a what is it called? A Teensy 4 that sends the commands to the motor and redundantly asks the motor constantly, what do you think you're doing? What are the encoder values that you think you're seeing, and so forth? So it says, I expect this thing to be going at 0.1 meters a second, and the encoder values no longer agree with that. Something has gone wrong, and it issues an emergency stop to the motor controller. So I have to redundantly have a safety test on the motor controller to see if it's going, just like it listens to the temperatures on the motor, it listens to the temperatures on the motor controller. In theory, it would listen to the battery temperature and all that. If the motors get too hot, it shuts down the motor controller. If the voltage range the voltages go out of range on the motor controller, it shuts it down. So there's all these redundant safety systems I have to put into this thing because they all represent things that have gone wrong. And when motors, so
I need more reliable connections for that stuff.
Yes, but I need to build my own. Well, I suppose I could solder on wires instead of using those connectors.
I was using a lot of custom made ones that had the 2 rows, so
Yeah.
it wasn't just a single row one, it was a double.
Yeah, 2 rows, yeah.
It's like the arms on this bot have a lot of those, like a couple for each arm that'll have 6 or 8 wires in each
Right.
in each connector. But I still get the and so I guess I need to do redundant power connections or something, but I get the just power dropping. I get my onboard PC shutting down on me too much. I don't know what it is, if it's just like vibration and like what you described, like a glitch in the power that way, or if it's a problem in the PC, the little.
Well, fortunately, I have 2 computers. So on top behind me there, you'll see a classic. It's an ATX case PC. And then I have now 2 Teensies that are down in the bottom plate of the chassis. Well, the Teensy and the PC send heartbeat signals to each other. So, and they're also sending some interesting sensor data. So if either one detects that the other's not doing what it should do, in theory, it should shut things down. It doesn't in all cases right yet, just because I haven't written the code for it. But it's, you'd kind of want to get to a tell me 3 times system, voting system or something like that. But I'm happy with a binary system at the moment. At least that brings reasonable safety to the
I used a voting mechanism a lot for obstacle avoidance and emergency stopping, of course, because there's like depth and sonar and the tilt on the compass and the terrain map. So there are like maybe about 5 things that would have the potential to vote, or that would vote in this kind of safety evaluation that happened. But so you've been a member of this, coming to this club for a number of years then.
Yeah, I wasn't for a while. So I was in this club, 2 generations ago or 2 locations ago. And then for a number of years, I did not join the club. And then about 4 or 6 years ago, something like that, I joined again. And now I'm a heavy member here. I'm show up at the Tuesday SIGs and help people solve ROS problems, because I'm one of the few people who actually reads the ROS code to figure out what's going on.
So the general's coming up next week, and I'm doing that. So any advice, having seen lots of these over the years, as to what goes over well or what doesn't, or stylist, just anything about that in terms of those generals?
Well, the easy thing to say is every one of your lectures I've seen are just perfect for the audience that you're going to have. So the audience itself, we have vaguely 1,000 members in the club. There's about 70 that are candidates for showing up at meetings. And there used to be 70 that showed up when we were over at Google. Now that Google is, doesn't allow members over there. We're over at Maker Nexus, which is a fascinating place. I'm a member. And we have about 20, 30 people that show up there, and about 20, 30 people that show up on the Zoom call. And we're now gotten to the point that we understand that we have a stronger control about how presentations work. We try to prevent people from causing the meetings to go into chaos on these things. So the type of thing like you did today, where you've got slides, you talk to it, somebody will look at the chat and tell you in theory that, Martin, somebody's asking a question here. People will try to butt in and answer and so forth. Of the people that show up for these things, probably 2/3 of them are building table bots, but they're all fascinated by all the other stuff. So they may not understand your explanation about how a correlation, the neural networks work, will probably be understood by most people. I don't think people are going to ask you how the weights are computed and how back propagation works or any of that sort of stuff.
Yeah, there's people all over the spectrum, it seems like. There's some people just really deep into mathematics and that side of things. And then
we've got more than half a dozen people that are pro roboticists, PhD level, researchers and so forth. But there's on order of what I would call 6 people that are doing my level of robot, somewhat serious, not trying to design everything, heavily relying on ROS, but developing original code, original intent, things like that. But everybody wants to get to the Fetch a Beer robot or better. So everybody's a real thirst for knowledge on there. When I go to my ham radio meetings and they talk about antenna theory, I don't understand that. I've got a minor in electronics and I still don't understand, transmission lines and things like that. But every time I go, I get a little more out of it, sort of thing. I know enough to just get the concepts and get a little more every time. So just do like you're doing. There's feel free to tell people that's a good question. I'll get to it, or ask it again at the end of the thing. Don't let people write on your meetings on this.
My hardest part is usually time constraints, because there's like any of these things, literally, there's always 5 times more that could be said about them.
Yes. And
coming from someone that's excited about that topic, it's really hard to do that. Like, how do I mention, like the one I'm doing next week, I have most of it kind of plotted out already, but it's like, I don't even have time, just, like for example, the whole question of pathfinding. I barely have time enough to mention the word pathfinding, but that's a whole thing in and of itself. Or
I think on my behavior tree, I think I might have recorded the whole thing and then stopped it every now and then to add a point or something like that. But behavior trees are so big, if you don't understand what the limits are, finite state machines and all these other things that are similar to behavior trees, trying to refine that down to, you've only got really 90 minutes to talk on this thing, and people are going to eat into that time on you too. And Camp is not as good as I would like him to be, to giving the speaker the flexibility of time and so forth. and for a lot of reasons. It's not that he's doing a bad job, but you've got that 90 minutes. And so my only thought was I've got some things I definitely want to get through on this thing. I don't want to get halfway through and find out I've run out of time. So I just recorded the whole talk and then stopped it. So it added a little bit to the length of the talk, but at least I made sure I got through everything on it.
So when you say recorded it, are you meaning you played
Yep,
a
I
recording
made a YouTube video and just played it.
of yourself giving the talk?
Yep.
During
Which
the,
allowed me to go through, of course, and do all the edits and things like that. Yeah, I sat and wrote a script for it and tried it over and over and said, oh, the talk's too long. Let me drop out this segment. Let me try it again. And yeah, I probably spoke the talk to myself 6 to 12 times, recording it before I finally got it down. So not that you have to do it that way, but
yeah.
there's a lot you want to say and you want to get to the end.
Yeah, well, I got to remind myself with this other thing I'm working on, just how new it is and like just basic it is on a lot of those like core things. You know, as compared with obviously so much work has been done, you know, in robotics. So, you know, like so many times when people try to build a robot, like you learn kinematics for the first time, or you learn pathfinding for the first time, or you learn decision trees, you know, and you integrate it and then you move on to some other idea. And 2, 3, 4 years later, you're lucky if you can come back and like do a second round on that.
Yeah.
I'm trying to figure out what the point to that is. It's just, yeah, it's just hard. You can't know everything, or you know, like, so I get excited when I talk about stuff that I happen to know a little bit about, but then I'm also realized that, you know, it's still this small. Like there's people that know, you know, people that do neural nets. Here I was like talking about like.
Did you see the talk last month? The guy.
No, I did not.
Oh man, you ought to go. You ought to go back and see the video of that.
Yeah, I heard it was really good. What do you think?
In the middle of this talk. So this guy has spent 3 years doing this humanoid robot.
Okay.
And he's done, just a fantastic implementation of this thing. And if you look at his blog, he's got all these talks about, you know, why he chose the motors that he did. And he shows this thing about speed versus torque and things like that. And if you have a motor that's trying to emulate a human, you know, well, a human doesn't have the problems about a weight on the end of the arm trying to control it. You know, the weight is evenly distributed throughout. So you don't, and robots typically they put motors somewhere. And if you stick motors on the end, it's hard to move a motor fast. Yeah, it's hard to move weight fast on this thing. So, and you know, his motor is controlled not by gears, but by strings, tight cords on this thing.
Gotcha.
And he explains a little bit about why he's made all these engineering decisions and how, and he's done just a extremely fascinating implementation of this thing. About 3/4 of the way through this talk, some guy jumps in and wants to talk about, oh, this can't possibly work. I tried this years ago, and goes down this rat hole for 10 minutes about it. And then he says, well, maybe you've made different decisions and maybe it'll work for you. And like, wait till the end of the talk.
Yeah.
And I always feel when I jump in while you're talking about some of these things too, because I'm trying to jump. You know, when someone gives a talk, I'm of the type that needs to, before you tell me anything, tell me why I should care. Where is this talk going to end up that I should pay attention to it? So now I know what I should be paying attention to down this thing. And I'm trying to map what you've done to how can I use this sort of thing. And to short circuit and not steal a lot of time, I'm trying to make a lot of assumptions when I jump in and ask you things. And I'm finding out a lot of times my assumptions are wrong about this thing. And it takes me a while to figure out that, oh, you didn't mean that sort of thing. And I always feel bad about jumping in, but yeah, I'm bossy and I'm trying to get something out of these talks that I want to get out of these talks.
Yeah, I think it's fine for the VIG, you know, because we're a small group, you know, and there's nothing that I'm saying in any of these that's that I can't tell somebody next month or whatever. Like it's not, so we can be more interactive about this stuff. And by the way, anything that that you might like to present on in the VIG, not to try to twist an arm or anything, but if there is.
I don't think I have anything that would be of interest to you. A lot of my stuff is on what I call tricky programming. So I have 6 software patents. I used to be an expert on how to, I vainly would say that I was a worldwide expert in how to debug complex systems. So I designed a debugger that would allow you to solve the problem of, I have a system that consists of a computer on Mars, the moon, and 7 countries around here, and something went wrong. And hard problems, when you observe the problem, is not where the problem is. The problem occurred upstream, and you don't see it as a problem until side effects occur. And to solve this, you have to have several teams of people competitively debugging this. So I designed a debugger that allowed you to work with multiple systems of different architectures with groups of people competitively debugging this thing to solve a complex problem. And so I have a series of software patents about goal-directed problem solving. So a lot of the stuff that I've done in my life is all in that similar vein. When I did this consulting problem for how do you tell what places are being talked about in this article, I had these things that, and you'll probably recognize this sort of stuff about agents and swarms and Blackboard systems and things like that. So I had agents that go through and say things like, look at every word. Is this word the name of a city? If so, write to the Blackboard. This is the name of a city, 100% sure of this thing. And then something else would say, is this a prepositional phrase? Is this saying from Des Moines or to Des Moines or about Des Moines or something like that? Then they'd write to the Blackboard, this is a prepositional phrase. And another thing would come through and say, well, if I see Des Moines, is the name of the state mentioned in it? If I see Dallas, do I want to see Dallas, Texas? Or is it Dallas, the lawyer's name, or Dallas, the character in Bloom County comics and things like that? And I would write, yeah, I saw the Texas name. And are those things, what's the distance between this state and this phrase? So I'd write a whole lot of stuff to the Blackboard. And, then I had I used to work on search engines. I worked for Alta Vista and Bing. So these things just solve big polynomials, given a whole lot of indications. You have features, you assign weights to all the features, sum it all up, and that's your score for how relevant this page is to whatever search you're doing and things like that. So anyway, a lot of the stuff that I do in my real life, like programming and all that, is all about tricky programming. And I could probably come up with a lecture about how I want to use a lot of the stuff you're doing, like NLP and things like that, to solve problems that I want to solve in my robot. But I'm not trying to solve. I'm not trying to build a companionable robot. I'm trying to fetch a beer. I'm trying to my robot.
Do you have an OpenAI account? Like
I have a free one, yes.
Yeah, that's all I have. So have you used their interface yet for
I've only used it to do the Dolly stuff. That's all.
Oh, okay. So you haven't tried the
No.
the chat ones yet?
No.
Because I'd be interested in talking after you've tried that and after you have tried having it return, like just hypothetically, like just start getting it to return its results in like JSON format,
Mhm.
and then start to get it to do one or more things inside that JSON that it returns. And so, like, to me, what it becomes is it's a computer of sorts. It takes natural language input and it gives whatever output you ask for, but it's not necessarily natural language output. It could be just JSON with something embedded within that, which might very well be natural language. But I think there's too much energy that gets hung up on what this thing can tell them and whether that's amusing or not in a conversational sense. And I
My
probably
intent was to use this to, if I understand this right, I need to write a fairly long prompt about what describing the robot, its capabilities and so forth. And then the sentence that I want to give it is essentially all the sensor input in the goal. So I want to say, fetch the beer. And I want to say, here's what the sonar is reading. Here's where the walls are. I've taken the LiDAR and I've written wall detector code that looks for, points that are contiguous and looks for things that are at least certain lengths, and then wants to find things that are perpendicular to each other and says, these are likely walls and so forth. So I can describe walls with, AMB type things with the length.
probably know what ransack is.
Yeah, it uses ransack to solve this. I didn't write all of this code. I wrote the thing that took line detector and then equivalent to the Huff line sort of thing, and then tries to characterize those things as potential walls sort of thing. So yeah, but sort of I was going to give it the sensor input and the goal, and then try to have it format to me what to do about it. Go in this direction sort of thing. I don't know if I can do that.
Yeah, I mean, I think it's there are big debates coming on this in our community, perhaps, but what's the appropriate level of problem to put into its end of the tennis court versus what should be handled locally? Or is it a cooperative problem of some kind? Like, I think the approach I'm taking is to try to handle, so far anyway, try to do as much of it locally with like more traditional mathematics and robotics techniques. But then I can see that there's lots of things. Hey, there's obviously lots of things in verbal interaction that ChatGPT can make smarter, but then I couldn't pick things up and put things down, for example, in even the simulator until the last couple of days. So that's only when the possibility of giving an instruction to like do a childlike task became like an option. So I think that's, an appropriate use of ChatGPT is for like high level planning.
That's what fascinated me about your thing where it was picking up the blocks. So that's what I was trying to get at, is you didn't have to tell it that when I pick something up, it is with me when I move. If you had to try to feed in all that knowledge to a logic solver, that, it's an intractable problem, essentially.
Yeah, and time will tell on that, because I haven't really validated yet how much it does understand. I got impressed with the initial result, looked logical, and I was like, okay, it seems to get it. But then at times I get a response and I'm like, no, it really doesn't seem to get it. So I think figuring out, the
but
prompts.
if you took that output, you could take the output and verify it. Could this solve the problem? Coming up with a solution is the hard part. Once you've got a proposed solution, verifying that it's feasible, that's much, much easier. So,
yeah, I agree with you on that, because I think what I can do, for example, is I can simulate not without going through all the steps. I'm sorry, I can do it without going through all the steps, I think, is simulate what would happen if I followed the plan that it gives me. So it gives me a plan, I can validate, oh, okay, do all the steps look okay? I could maybe even have a thing in there that would take a step and send it back to Chat GPT and refine it a bit or something. But let's just say we're past all that. It could then kind of visualize forward to say, if I did all these things, what would the state of the world be in simulation?
Yeah.
And if that looks okay, then go ahead and execute it in simulation.
Yeah, I feel bad that Alan is not talking here, like we're talking over him.
Yeah, is he
No,
muted?
I'm still listening, enjoying the conversation.
Yeah, so
Alan, we
I'm just
gotta get
enjoying
you
the
a better
conversation.
mic, Alan.
So
I
there-
don't know. I'm my phone, so it's not doing too well today.
It got a little bit better there toward the end,
yeah,
just now. Yeah.
Yeah,
You
Yeah,
can-
sorry about that. I'll just shut up again. I'm listening. I enjoy your talking. Keep on going.
Yeah, well, we need you in on these. So,
but if you look
Yeah.
at, Marvin Minsky's work about, or maybe it was Alan Steele or somebody, when we were talking about solving the monkey fetching a banana by putting blocks on each other, basically you just have a thing that understands possible states. So, when you have a thing that says grab the green block, okay, now the state is I have a green block in my gripper. And if the next thing is go to a room and grab the red block, you could discover that it's violated a constraint. I can only grab one thing. And it knows enough to not try the plan. And if nothing else, you could just stop and say, I need help. And you could add a new rule in to force the chatbot to better recognize the grab one object sort of thing. But just recognizing, can I go from state A to state B, and then what's the resulting state? That's a fairly, well, at least relatively easy thing to do to check the feasibility. But coming up with that states, like I say, is the hard thing, because you don't want to do what Martin Gardner used to call the BFI approach, the brute force and ignorance. You don't want to try to solve chess by generating all combinations. The search space is too big. For it to creatively short circuit that search space and come up with something pretty slick. And DALL-E, when you tell it to generate an image, it tells you generate 5. Give me 5 different images. I'll see if one of these looks good. I don't know if, since I haven't used ChatGPT, can I input this thing 5 ways until you give me 5 different solutions to this thing?
Yeah, the main benefit I've felt like I've gotten out of DALL-E so far is it'll create some really weird images for some things, but I don't have to worry about copyright. So if I'm given a presentation, it's nice just to be able to put some DALL-E stuff in there, and I just don't have to think about whether I'm violating something.
That's what I was showing before you got on. Let me share my screen here if I can. Yeah, so in DALL-E, I told it to generate an image of a red fox leaping at an egret. So that blob down the bottom is a red fox.
It's like a fish.
Yeah, there's a red fox with a squished face and a tail that can't exist. That is hardly leaping at the egret. That's not leaping at the egret. And the egret has transparent, face next to its beak. That's conceptually sort of interesting, but not vaguely resembling a real fox. Look at that tail, and so all of these things are, just bizarre.
I thought it was interesting when you showed that, and your conclusion, I think you said at the end, was that something about it being really bad or something. I can't remember what your word was.
Well, it's certainly not useful for what I was trying to do. Yeah.
Yeah. And
Yeah.
yet, I think a lot of it's just kind of perspective or how people look at it. Because, for example, I've been trying to, the stuff that I've been creating has been mostly like pictures of robots in 3-dimensional rendered spaces.
Uh-huh.
when I do Dolly, and it'll just throw like random weird text in there that looks like it's from Russian or something, you know, and I'm like, I guess I look at it and then I look at what you got out of your more natural scenes that you're doing in the glass half empty, like, wow, isn't it amazing that an AI can create,
Sure.
can implement these concepts in a visual space and get even remotely close.
I agree with you.
And like 3 years ago or something, it seemed like we could barely get it to recognize a bird that was like the same size as their training images, you know, with nothing else, you know.
Yeah.
But yeah, obviously there's a lot of improvement to be done. It's just a question of half empty or half full type thing, I guess.
Well, one of the things, was it last Tuesday, or the Tuesday, one of these Tuesdays, somebody got in and asked one of the chats to generate ROS code to do something that a module typically does, I forget. But it generated a small ROS program that was almost correct. And my concern was, is the guy who asked for this going to understand what's wrong with this program? Because, you know, if you just casually look at it, it's almost correct, sort of thing. But that I'm much more forgiving about, because, yeah, it's just, well, it's almost correct today. I can see where, yeah, a few more years, it'll be much closer to correct. So.
Yeah, what 4.0 and what 5.0 will do, or I can't even imagine how it'll compare to like the 3.5 that I'm using now. I haven't been using the 4.0 yet. One of my pet ideas has been to try to come up with something that a robot could have a thought of that it wants to improve upon itself, and to for the robot to build a prompt that it would send to ChatGPT to write some new Python function, and then incorporate that into its own code base and meaningfully hook that new function up in some way to some new capability, some new skill. Like, can I get a robot to have I mean, you know, maybe even if I'm the one that has the idea, maybe that's okay. I'd love to find it to be able to say, oh, I don't know how to directly multiply numbers. Like, it could be something that simple. And then if it could go to ChatGPT, get it to write the function, which it'll write a lot of simple functions fairly easily, but then how to take that and integrate it right back into, say, the verbal features, and have it so that, you know, like in my case, I've got a graph and I have certain things that have to be in place for that new function to work. So I don't know. I'm hung up on that idea of, can I get a robot to self-improve? Because in the sci-fi movies, many times that was the thing that they wanted to prevent the robots from doing, so that they never had the robot apocalypse. It was like,
yeah, I was just going to point out, that's always the science fiction thing, is you give it an evaluation function and the robot will just blindly maximize that evaluation function, obliterating the world in the process because it doesn't know any other constraints.
Yeah. So I don't know. I'm interested in that, and but also maybe before I even get to that, like, and Alan, I think this might be applicable to any collaborations that we might want to do, is I think it's getting this better and better ability to refactor code. So the potential of using it to refactor our own robot creations.
You mean refactor in the classic sense, about, you know, taking a function and turn it into two functions, or something different?
Yeah, I don't know exactly. I'm just thinking that, like, my own code has accumulated dead code there's things in it that aren't used anymore or deprecated, or there's potential logical errors or bugs in it. So
Well,
when do we make,
I worked for Microsoft for a short while when I worked in Bing and then in their audio or visual video tools
Right.
thing. And even though Microsoft was by far the worst company I ever worked for, hugely poisonous place to work, I learned that Visual Studio is God's gift to programmers. And if you want to refactor something, Visual Studio is just a magic toolbox.
I worked for a Microsoft technology solution provider in the Bay Area for 5 or 6 years. So that was mine. Yeah. And I was a Visual Studio person for a whole lot longer than that. At other places. I was basically like a roaming software architect. So I'd just go to whatever city or gig as a software architect. That was always my thing, because I was always, my big thing was finding ways to eliminate the code for everybody else. So to me, the best code was always for people not to have to code to begin with. And at least in those days, the primary technique that I used to do that was basically metadata driven frameworks. I'm like, okay, if people aren't writing code, like you can create metadata with a lot more reliability than you can code. So, anyway, that's a long topic in and of itself, but
sounds like you're a good Ruby programmer.
When you mentioned Microsoft, it made me think our paths might have crossed. But I remember going and, because I had clients all over the Bay Area. I remember back in the .com bubble lead up and after being at Ask Jeeves there for a tiny bit, just talking to them. I can remember talking to PayPal when Musk was there, or when they were first doing that. Biggest thing I ever did in the Bay Area were the Gap brands, their e-commerce stuff. That was the thing in those days, which is quite boring, but that's like the first 2 use cases of almost any new technology is for porn and then to sell khakis and t-shirts.
Yeah. That's a thing I was least interested in, is any of that enterprise stuff. It's
not exciting.
Yeah, I did not need to know yet another way to do remote procedure calls or pass data around. Did not interest me at all.
Well, I got a quick question. I'm gonna have to sign off, I think, here pretty soon. But I just want to, on the ROS side, like, how does it process verbal, and how would it process something equivalent to what I might call a narrative, or like a list of things? Like, if we had that same thing, of a plan, for example, how does ROS?
The easy answer is kind of not at all. The less easy answer is, so when you want to fetch a beer in ROS, assuming you've already implemented a thing where it's got SLAM going, it has a map, it knows where it is on the map, sort of thing. ROS is then driven by services. So, in ROS, there's two things: a service and an action. And a service has an immediate response, and an action has continual response. So you poll it, ask it how it's doing. So the navigation is done with an action. So you say, go to this XY coordinate, and the action that handles that sends it off to a planner. And if the planner fails, it sends you a response back saying, I cannot plan to go there. Otherwise, it uses the behavior tree then to figure out what should I do. And the behavior tree says, well, go forward a meter, let's see how we're doing from there. And if you pull it, it sends back a partial response saying, I am continually working on this action you've asked me to, and here's the new state of the robot as a result. And you keep pulling it until it either fails or succeeds. So a lot of the brain of ROS is built around the concept of actions or services. So.
And I would think that's necessary, on any system of any sophistication. Like, because I'm thinking about like Ava is not any different. It's a different implementation, but really there's a bunch of services that you need to move around.
It's kind of a big e-commerce site, essentially.
In 3D space, but like an e-commerce site's kind of like waiting for somebody to do something, but a robot, it's got all these services that are kind of running.
Most of them aren't doing much until you do something like, say, move the robot. So in mine, I've got nodes that some my teensy is reading all these proximity sensors and the temperature and the motor current and things like that. And it packages those up into ROS messages and it just spews them out. If you care about the distance from sonar 0, here's what it is. Here's the distance from sonar 1, sonar 2, and so forth down these things. And so, and if you are running the visualization software, you tell it, I want to visualize that thing, and it'll subscribe to the sonar. And, it's got a model of the robot. So it, generates a visual picture of the robot. And then if you want to visualize the sonar, it can generate a cone, and you get to customize the color of the cone and the alpha channel and all that sort of stuff for it. But all of that stuff is sort of static, publish and subscribe, generate a lot of state information, visualize the state information on it. The only thing interesting happens, and really happens in the motion planning, and there's really two kinds. There's the move the robot and there's move the arm sort of thing. And those are kind of two different planners for the thing. And once you generate the plan, you can ask for it to just generate a plan, or you can say to execute the plan too. And once you say execute the plan, then it has the different, it does it differently in ROS 1 and ROS 2, but ignore ROS 1. ROS 2 then just hands off the goal to one of the various behavior trees you told it to use. And the behavior tree, there's one that says, go to a waypoint. There's half a dozen of these behavior trees out there, high level behavior trees that have a whole lot of other sub behavior trees in them on there. But those are the things that actually cause anything to happen. There's, if you don't have a fixed map already, in which case you're in the mode of generating a map, then AMCL is running the auto something Monte Carlo, adaptive Monte Carlo localization. So it's doing a lot of computation to every time the robot moves, it takes the past view of the world, all the sensors, speculates where the robot moved to, tries to figure out what was the best place you move to, and it generates a transform from the map to the odometry. And ROS works with a transform tree. So you describe your robot in terms of cubes and cylinders and things like that, spheres. It'll generate a nice little visualization of your robot. But all the components are linked together by, you generate links and what was the other thing called? I think, but one of those is, links and joints. Yeah. So joints move, you have transforms between joints. So it builds this big transform tree. So,
I know what you mean.
Okay. So you can ask, if you're given a sensor reading from a depth sensor that's hanging out on an arm, and you want to know where is the bottle of Coke relative to my left wheel, it has the library that tell you how to do all the transformations or all the arm joints and everything like that, and figure out where that is on there. So there's a little bit of computation that goes on to maintain the transformation computation. That stuff also has caches and histories and things like that. And it manages also this whole thing about, if data from the sensors is too old, then I won't produce the transform for you and things like that. But the two big,
Is there a verbal interaction
not at all.
set of services for ROS?
no. There may be somebody that has created modules. So Ross has on order of 10,000 modules in it. Most people, generate, pull down the standard ROS and use, as far as they know, like 6-10 direct modules, which implies that they're using maybe 100 modules indirectly and so forth. But there's a massive amount of stuff in the ROS ecosystem. So there may be out there.
And a lot around movement and
Localization, yeah.
all that,
Yeah.
sensors. Yeah. That's
Well,
where
the move base is the thing that, is it move base or move it is the thing that used to be do the arm movement thing. And it had a whole lot of stuff for inverse kinodynamics on the thing. So I don't know how the new one works at all. I haven't looked that far.
I remember when I wrote my first robot in Arduino, and then when I moved on to these others, like the big Ava one, it was a similar concept, but it was like, okay, is there some mechanism for the robot to have either a list or a hierarchy of things that it needs to do, where it can reach down and make any state change that it needs to make at any level?
It's kind of what behavior trees will get you.
And so do I get that composability where once I have those things, can I then remember those things and reuse them and have one refer to another so that I can, because like if you take a ROS robot and let's take something of the level of sophistication of say an InMove robot, but maybe on wheels rather than legs. So the thing can actually move around like on a wheelchair base or something. Then how would ROS orchestrate like, the movement and the arms and the face and the eyes and all that and gesturing? Like what's the mechanism to control all those little movements at the same time to coordinate them for some purpose?
So if ROS doesn't already have an InMove module that does this better, you could do it with behavior trees. And that's because this whole thing about reactivity and the behavior trees. So in the behavior trees, if you do them probably the more correct way, and you can use behavior tree badly, but normally what you do is you set up a bunch of preconditions and then actions. And behavior trees work by producing a tick. So you advance the clock one tick and you send the tick down to starting at the top of the tree. And the trees, there could be a sequential node. And its purpose is to do these things in order as long as the leftmost part has succeeded. So when the first thing has succeeded, do the next thing. When it has succeeded, do the third thing. There is a thing called, I forget what it's called, but if the first thing, it tries to do the first thing, and if it fails, it does the second thing, sort of thing. So this is, the sequential thing is sort of like, I want to go from here to there. I want to grab this thing. I want to go to the next location. The other thing is like, I want to move forward. And if I can't move forward, then I'm going to go to this recovery thing that is going to choose a different way to do things, sort of thing. And
I think I'm trying to follow if you needed to do, say, 47 things, okay, on
most
a
of
ROS.
these are done by precondition, so you need the robot not to fall over. So you'll have a thing that says is the center of gravity in the about to fall over state. And if it isn't about the fallover state, you want to ignore everything else and you want to focus on how do I get this thing into a stable state again? And just like, and these things can be all done in parallel.
Yeah, I get it. I mean, I've lived in that and I can visualize that. I think what I'm trying to get at is like, let's just say you have all these services and you have all of them doing their
Right.
sort of what I'm going to call maintaining some form of homeostasis, some equilibrium safety thing that they think they're doing.
Right.
But there's some higher level thing that you want to accomplish, you want to do, okay, that you don't know in advance. Like I can't say what it is, but I know there's going to be 47 things I need to do. I'm just trying to figure out like the nature of ROS and how it's constructed. Is there a way to write those 47 things down in some, does that have to be programming or does that have to be, is everything a function that can somehow be called generically? Like, is there some way to, in a database, to store a list of actions that you want performed and it can delegate them generically? Like, how do you get,
like even when you fetch me a beer thing, what you do is one of the high level things says is I need to create a path to the beer. And it calls a service that creates a path for you. And most of these things in behavior trees that work by writing knowledge to a blackboard. So the path could be then written to the blackboard. And now the sequential thing says, now that I have a path, the next step is to execute the path and execute the path. So there's two planners in ROS. There's a global planner and a local planner. So the global planner, when you say you want to fetch the beer, creates a plan based upon just global knowledge. It doesn't know there's a cat in front of you. It knows the map of the room, knows where the beer is, where you are. It knows where the doorways are and things like that. And then it hands off the plan to the local planner.
And what does the plan, what is that constructed in, or what is that, how is that represented, a plan?
It's a list of vectors of positions to go to. Conceptually. So to go to this point, make a turn, go to this next point, sort of thing. And so the local planner then takes each segment of that, well, actually breaks it up into little segments and says, now just look around me, like you tell what the distance is the local planner should be concerned with. So if your local planner is concerned with 3 meters around you, it just looks at all the sensor data within 3 meters and tries to move you along the global plan, avoiding obstacles in the local area, sort of thing. And if it ever comes across an obstacle that it can't avoid, it just punch back to the global planner and the global planner will try again, sort of thing, until the global planner says, I cannot solve this problem. There's obstacles everywhere. I've tried all the backup strategies and things like that. In which case the original action will report failure and you need to.
So if I wanted to do something like, I'll just pull one up. So this would be an example of a higher level task that a longer range plan of checking the house.
Right.
And so what it needs to do, and it could have multiple trees to go down, but in this case, it only has one. So this is it's the same every time. So it's just this plan is to check these other rooms and to say something.
That a behavior tree as a sequential node, and each one of these would be a subtree. Check the living room, then check the den, then check the dining room.
And those are other things that have their things, and and hopefully nothing goes into an infinite loop or it needs to detect it and figure it out and not do it.
Right. The check living room would have a subtree below it that would say, am I near the living room? If so, go to the next sequential thing, which says, go to the living room. If not,
so in my realm, that I just attach a needs level to it, which evidently it's just doing it to feel good about itself. So it's a level 3 self-esteem thing
Okay.
of it's doing its chores, and it derives a benefit of feeling whatever good about itself for doing that, for
Mhm.
doing what's expected of it. And it looks like I don't have a date expectation on it. So let me go to another one that has a time expectation. So this one, apparently I want it to check the dining room every 5 hours if
Mhm.
it's awake. So that is, so these are, what was that terminology again? Because I want to look that up. Did you said decision trees?
There's sequential nodes and fallback nodes. These are behavior trees.
Behavior trees. That's what I want to look up. Okay, I'm writing this down. So it's like any other related things then, because I just want to see like how other people approach just like capturing some plan of action.
Let me point you. Let's see if I can find the YouTube thing. Here we go.
Order.
This meeting is being recorded.
Recording in progress.
Oops.
We'll start things out with
Oh, sorry.
robot news.
Oh, that's the
What's happening?
YouTube channel here. So let me give you a link to the meeting where I do the behavior tree thing.
Oh, okay. Yeah, that'd be great.
So yeah, skip the
Like
usual.
to-
You'll see how a common meeting goes if you look through this. So it starts out with Camp doing all the show and tell and robot news and all that. And that goes on for a half an hour to an hour. And then you jump in after that.
Okay, so I got that link saved. Awesome. All right, well, I'm going to check that out because I hopefully before we get the general next week. Because this is right in my stuff I need to be thinking about right now anyway.
Yeah, and there's a lot of good YouTube videos on ROS and behavior trees. I've tried to, there's 3 or 4 people that have a lot of seminal knowledge. So I went and read all their papers and tried to reorder everybody else's stuff and put it down to, without getting into all the edge cases and things like that. What do you need to create a practical behavior tree to do interesting things? So, and there's kind of a right way to do it versus, make up your own thing. There's sort of a thing that is more mathematically correct than other ways. So I tried to get that across here. It's not provably correct, but it's more likely to generate a good behavior tree if you do it this way.
I feel like all the mathematics that has been built up around robotics is still very relevant.
Yeah.
Like I see like stuff come up in discussion, and it's like people see a new shiny object or new tool and they think it replaces all previous tools or something. And so to some degree, I think that's going on with the language models. That's the big one now that seems to be happening with.
Well, you have facial hair of the right color to know that this just happens all the time, and a lot of old knowledge and wisdom is forgotten, and people keep repeating the same mistakes too.
So there's that going on, but to me, I see it just as like a new tool, and as a person that has to at times work on a lot of stuff, I understand the value of having the right tool for a given job. And so like kinematics, is a tool, and vector math is a tool, and what all these different, like you need DH params to work out kinematics, or you need whatever, basic being able to calculate physics or something, but then all of a sudden now we have all these new capabilities that like, hey, there are some things that, I'm still not convinced that ChatGPT does well, but I'm hoping that it will, like on this planning. But I'm already just amazed at how much it can simulate, for example, personality and emotional states and psychological conditions
That's
of
what
like
the shiny new object interest seems to be right now is
like all of that is amazing. And then a lot of people aren't talking about it, but they're just, maybe interested in what it can do in that regard. But what it can do in interpreting that from you is also very amazing. So there's a lot of capabilities. I'm rambling, but it's like, I'm kind of thinking that and wondering, it can't be ignored either. So I wonder, like in the Ross community, are they grappling with the meaning of, like, for example, just, the elephant, which is Chat GPT, I think, or are they just see it all as an amusing sideshow for now? The fact that if Ross doesn't have verbal capabilities means it may be like men are from Mars, women are from Venus. It like it doesn't seem relatable yet.
most of the robots now aren't intended to interact verbally. They are, welders, or there are things that carry food from the kitchen, to the table, or deliver, food from a restaurant to a dorm room, sort of thing. Those things just solving a very narrow problem.
I guess if we don't count all the Amazon Alexas and Siris because they don't have motors and move, then they wouldn't fit the definition of an embodied robot. But then, cars, that's a thing. And then if someone puts some little legs and arms on the cell phones, then all of a sudden it's a different ball game. Like I don't know, are you questioning the value of a verbal interface in that?
I don't know that I'm questioning it. It's just that it's another gizmo and it has its place, but I don't know. I mean, like telephones have a place as a verbal thing.
I guess it's the use case of robots in general, maybe, because I'm working in essence on fictitious robots. Like the robots don't even exist really. If you think about it, they exist in simulator, or they exist in like the mind's eye of imagining a good robot. But the reality is the robot's off most of the time. So robots
I suppose I suffer from a limited vision on some of this.
So Martin, have you ever looked at the at-home competitions?
No.
Have you seen the at-home competitions? They're big kind of international competitions with a lot of universities in. Most of their robots are Ross, and they almost all have verbal interfaces. The idea is that it's a home, it represents a home, and you're trying to have your robot go around the home, and they almost all have natural language processing interfaces. And you'll ask it to set up the table, and then and all these other different home tasks. So
I guess when Michael said it, there were 10,000 services. It's probably in there. It's just not part of the ones.
Each university has their own version of it, basically. And some of them are open source. Many of them are not open source. But I have looked at a bunch of the open source ones that were available a few years ago.
You're talking about the verbal side of
the verbal side with the Ross underneath. They almost all ran Ross.
So were you impressed with what you saw at that time?
They still barely work. Most of them do not work. Most of the tasks fail. And it's kind of like the space one where you're trying to pick up the rocks. Half of them don't actually, succeed in getting out the door or starting up. So
if we could get anybody to do it, meaning like if you were willing to do it or anybody else that wanted to, I would love to like to do some retrospectives on like dig up, like I have a robot that I did almost 10 years ago that had a lot of verbal stuff in it, which I would have considered it to be something close to state of the art at its time or ahead of its time way back then. But I think it could be fun to like talk about these and what's changed since then and how much we've learned. So even like a retrospective on like the Ross robots and what they could do would be really interesting if there was any way to dig any of that stuff up.
I'd be happy to sit around in a restaurant some night and swap war stories with everybody about all this stuff.
Probably get Melanie Wise or Mike Ferguson to talk about it.
Yeah. Well, like I say, I started back in kerosene computers, and I used to run 3 businesses at the same time. One wrote compilers, one designed computers, and one automated a law office using artificial intelligence. And I've designed supercomputers for black projects for the government, written compilers and debuggers, and worked on search engines. I got lots of war stories that swap with people, and I love to hear other people's stories about things. I find them very inspiring, and they give me a lot of ideas about stuff too.
Is there someone in the Ross group that would do that?
Do which? Run a retrospective?
No, yeah, come to the VIG and do something on, one of these Ross bots that did the type things that Alan was talking about. Is there someone that knows the subject matter? Or Alan, if you were up for it, I just didn't want to.
Nah, I'm not the right one for this.
Several people in the group that were part of Willow Garage there, they might be good candidates.
Well, that's what I was thinking of Mike Ferguson. He lasted all the way through Fetch, so.
Yeah. Dillo's in there, but Dillo is not necessarily an effective speaker, although he's got a lot of great war stories. Ferguson's pretty focused in the speaking. He's a good speaker.
Would you try just asking around one of your Ross things? If anybody might be interested in
just send something to the email list.
Doing a little thing on that. Yeah. Because I'd be interested in knowing more about that and then figuring out if there's some ideas or whatever that need to move forward with the stuff I'm doing, or if I need to forget this line of thought and.
Well, if you go back to the PR1, when I listen to people talk about what it did, you start getting into this. Well, has anything advanced since then? Apparently the PR1 did everything. Still struggling with the same problems.
I think PR1 actually started off as an at-home robot, didn't it?
I don't know.
Yeah, something.
But Martin, that Honda robot that can walk around.
Yeah, Martin, I recommend that you do look at the at-home. There's normally these videos that retrospect on it. It was only
I looked up at-home competition. I'm not sure I got to the ones you were talking about.
At-home robot. Yeah, I don't know what it. It was just it was just like a month or so ago, this last competition. They were all using the Toyota robot arm. Or a bunch of them were. And that runs Ross.
Yeah, I'm not sure I'm finding what it is you're talking about.
I just shut down my computer and everything.
Even if you send it later, that's fine.
Yeah, I'll try to send it out later.
Love to see that. if any of you guys have ways to make me smarter and more productive, I'd love to know that too. You know, my degree's in math, but I've forgotten so much of the math that I use. And
But your degree was math.
yeah. You know, I taught myself AI and game theory. You know, I got my degree in 73. So when I started, they did not have a computer science curriculum. So I had to make up my own computer science curriculum using advanced topics where you create your own program. So, you know, I taught myself 2-person game theory and N-person game theory and, you know, AI using perceptrons type thing and stuff like that.
Do you have an opinion on Alpha Zero?
Don't know what it is.
I think I have this right, that it was the second iteration. It was the big reiteration after Alpha Zero, or I'm sorry, after Alpha Go. So first the thing beat, you know, all the people at Go.
Yeah.
The AI, and then they made it generic, and the thing taught itself to play chess in about 4 hours or something, and became the best chess player. And I think they applied it to like all kinds of different games. So it seemed like it turned out to be generally applicable to coming up with strategies to win games. But I could be overstepping my bounds
Yeah,
there.
I'd like to see how they did that. I could tell you kind of a
I
war
think they
story.
were adversarial networks using reinforcement learning.
Oh, okay. To show you one of these, you know, tricky programming war stories. When I was running these 3 businesses, I had a friend that entered I think it was a weekly or monthly contest where he started out by solving these 3x3 arrays. Each cell had an operator and a number like +3 divide 4. You had to create a walk through all the cells in the array without lines crossing. And you ignored the operator in the first cell. So if I said +3, you just start out with 3. Then when you went to another cell in the little tic-tac-toe board, you did the operator and value. And the idea was to find a walk without crossing the path and came up with the highest score. So my friend did this, and he paid money each week to join the contest, and there was going to be a big prize at the end. So this went on, but after the 3x3s, the contest turned to 4x4s, 5x5s, and he got to about 8 or 9 square things, and he figured out he couldn't solve this by hand anymore. And he was a serviceman for Burroughs supercomputers. So he wrote a little program to solve it, and I think he got up to like 10x10, and he couldn't solve it on his computer anymore. So he came to me. And so I just used game theory to write a little program, and it got up to 12x12 that he could do on his little Burroughs computer. And then the final one came, and it was a much more complex thing. And he came to me and said, well, Mike, if you help me win this, I will split the winnings with you. I said, okay. So I wrote one of my tricky programming things. So when you're making a walk through this thing, one of the tricks I employed was if you formed an enclosed surface and you're about to enter into the enclosed area, without trying to find all paths within the closed area, just order these things so that if you were to do these things in this order, you would get the maximum possible score. Check that maximum possible score added onto where you were in the walk so far. If it didn't improve your score, don't bother searching. It couldn't come out with a better solution. So anyway, I had a bunch of these cute little search things that limited the search space on this thing, because this, you know, the whole problem was the search space on this thing. And I won the contest for him. And then he chose not to split the winnings with me. So
All right. Well, I have to take off now. You got, well, Martin, it must be like 2 o'clock in the morning for you right now.
Yeah, I think I got up about that early this morning, so I'm ready to go too. So
all right.
Love talking
All
to
right.
you.
Well, good night, everybody. Nice chatting with you all.
Thanks for coming. I appreciate everybody coming. It was it's nice to have an audience. when you do
Thank
these
you very
things.
much for doing the presentation too. Thanks.
All right.
Bye.
Good night.